Man, I just realized I was muted. I'm just... Ah, damn it. Dude, you know what? I was trying to record some stuff for YouTube earlier today, and I just realized I think I might have been muted. I think everything I recorded earlier today might be jacked up. Yep. Hey, 44, also hacked the planet. Age of 57, no, you're a nerd. And Hats, what's up, dude? Bro. I guess I'm glad I didn't get any more recording done because I only got a tiny bit done earlier today. Now I just realized the freaking microphone was muted. Uh, Professor Dumas, I know, man, right? Remember what I told you about the ESP32 recorder light? Yeah. Well, I mean, the recorder light wouldn't have worked to remind me that the microphone's off. So the main thing that happened here was I had my earbuds in. I didn't even notice the timers run out. God, I'm so out of it. I fell asleep before the stream, and then Sock came and woke me up, and now the stream deck doesn't want to work. Just everything. There we go. Jeez. Fight with everything. Now, a big part of that is I was up late a lot this week, partially due to work, because I got to fly out next week. I'll be in Charlotte, North Carolina, Monday through Wednesday. I'm flying back at the absolute peak hairy butt crack of dawn on Thursday. And so, but I'm going to be there for work doing stuff. So, thanks, 57. Yeah, it should be nice, easy travels. It's only, I don't know, I think it's like a 3-hour flight from Dallas to North Carolina. It's not bad. Claude could probably write C for both the ESP32 and OBS. Yeah, it probably could. You know, that might be actually a really smart thing to go put into OBS. It's like, hey, are you actually recording? In fact, hang on. Now I'm going to go check. So when I'm recording, I don't have my earbuds in. So I don't hear the live feedback from the monitor, right? Yep, I'm looking at the video right now. It is all silent. That's all right. We'll just delete that right now. Hide my shame. There we go. So I just mail you an ESP32 and some LEDs. Actually, there was one. Hang on, let me see if I can find it real quick. You'll probably like this foil. Hang on, let me see. Let's see. Display. Let me see if I can find it here. Here we go. Actually, I was thinking about maybe buying one of these. I think this is the one I was looking at. Actually, hang on. Let me see. There was actually something I was looking at. I don't know why. I went on a tangent sometime earlier this week and was looking at 3D display options. Yeah, I was looking at like how to replicate this. There we go. Hey, Potion, what's up, man? Dude, Potion, I'm liking the threat intel stuff you've got started over in the sandbox. It's looking pretty cool. I think it's a little bit of tweaks. I think we can make it pretty sick. So yeah, by the way, guys, there's a new category over in the Discord. It's called the Sandbox. And I put that up there for members of the community if they want to provide certain services or things, they can do that. So right now, Potion's got his own threat intel feed. He's kind of curating and building out, and so it's connected up there as a Discord bot. And then I've also got one channel set aside that I'm calling AI Fight Club, where if you want to connect one of your AI agents, because Guy wants to do that, he can go throw it in there. And so if you want to go talk to their agents, if you just want to see them fight amongst each other, you can do that. So yeah, I've finally decided to go build that out today. That's a specific alignment prism. It's not a real 3D display. It gives depth perception to 2D stuff. I know, but it looks really cool. I was hoping to be able to maybe use this, like at least maybe to give it like a kind of 3D view to it. I don't know. I wanted to play with it. I thought it'd be kind of cool. Maybe hook it up to an AI agent just for funsies in here. But it looked kind of fun. Hey, Bobby, what's up, dude? All right, I might have spoken too soon on the stream title because I'm sitting here, I'm trying to get registered over to Binary Ninja. And it's like, hey, we need to verify your email address. And I'm like, I already verified my email address. I'm trying to. You don't send me the damn email. It's like, I'm trying. I wanted to go through the binary jiu-jitsu stuff. Let's see. Like, nothing in spam. Like, there's just nothing. Let me in! Let me in! I got out of bed for this. I was looking forward to it. Yeah, I do have my own domain for the stream. So eventually I'll put a website up and some other stuff. Right now, it pretty much just handles my email. Is that the modern Horadric cube? What was the Horadric cube? Oh, the Horadric cube from Diablo. Oh, I guess so. I was like, I know that term from somewhere. Actually, I was thinking D&D, but you know what? Diablo's not too far off of D&D. Well. Yeah, damn it. I wanted to go through this because we talked about the binary jiu-jitsu stuff here on the stream. It looked really cool. It's like, hey, come sign up. I'm like, I want to. I want to be a level 1 white belt. Let me. Did you check your spam folder? Did you try to turn it off and on again? Reset your TCP IP settings? Yes, I've done all that. Clear your cookies? Yep, cleared the cookies.
Hello, IT. Have you tried turning it off and on again?
I'll ban you, 57. I just tested the site, was able to register right away. Well, F me running. Hang on, let me try something else real quick. I mean, don't get me wrong. You know, Ticker, I'm glad it worked for you, but I'm looking at like why you know like me. Hang on. Maybe it just doesn't like my email domain. Maybe it thinks it's fake. Let's see. Hold on, stand by. Okay, let me see. Okay, wants me to check my email. Dude, what the crap? That came through instantly. This is some bogusness. Hang on. I know it's like I didn't forget to like pay for the domain or something. I know the emails are working. I guess they just don't like my domain or something. Asshats. It came through instantly on my personal email. That's bogus. Yeah, IRL cleaning the cookies. Nom 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 nom. I got too many domains. I plan on stopping some static websites. Yeah, sorry, I forgot I was still in OPSEC mode. But yeah, one of my buddies, he collects domains like that so much. I want to add an RSS feed and RSS and Intel feeds that I'm currently running some ransom actors against ransomlook.io. Oh, nice. I guess so, dude. It's not even like I send any emails. This is purely pretty much an ingestion email. I think the last time I sent an email from this email system, let me see, where is it? Sent emails. I haven't sent an email. I sent like one in April. I sent one in May. I sent one in June. That's like it. I just don't send any emails from here. What the crap? It's bogus. It's bogus. It's wrong. It's wrong. Well, hang on. Here, I'll do this. Log in with my other account here. Hang on. Bogusness. Bogusness. There we go. We're in. We got 40 domains right now. It's a little bit of a problem. Bro! Just the maintenance on those 40, dude. That's like $200 to $400 a year. Last time I sent 38 million emails from the system. Oh, wait. Yeah. No, I at best, I'll send emails to, like, I send emails to myself. That's it. I was like, I don't even know what the hell's going on. Yeah, he's scalping domains, Bobby. That's what he's doing. I do have buddies that, like, they will just go buy joke domains. All right, let's see. All right, haven't earned any belts yet. Let's go hop in. I want to see what this is, because it looks pretty cool. Ooh. Oh, dude, this has music to it. Hang on. Make sure I got the audio set correctly. Yeah. It has music to it. Okay. Skin color, about as white as the Lily Snow, because I just need to get some more outside time. Eye color, blue, that works. Gi color, oh. Well, okay, so the old school karate person in me says, if you're just starting, you get the white gi. So there we go. There's no beard option? Rude, okay. Guess we're just gonna go with the newbie out of the cloning vat. Enter the dojo. There's a chat system in here? Oh god. I'm just jumping like straight into this. I don't even know what's going on. I don't know like what I'm supposed to do, where I'm supposed to go. I went into another room. The tournament? Nope. I'm not good enough for the tournament yet. Alright, so we're back to the music now. Oh, you know what? Let me do something. I gotta reset the zoom here. There we go. It's gonna make everything a little bit tiny, but this program is not meant to, I guess, adjust zoom in the way that I had it. Alright. What's this? This was not what I expected. Can I punch this? Can I punch this? Or are these seats? Am I sitting and watching the tournament? Oh, here we go. We've got a terminal now. Nice. Okay. Change appearance. Can I go to the gym, leaderboards? Hold on. I need a way to... As I've been told by dates before, gotta find a way to make this bigger. Oh, let me try this. Okay, pull up the terminal. I have no belt. Yo, this was not what I expected. Can I punch this and this? Me, every time I'm forced to use public transportation. Mommy bought me a pewter for Christmas. That's right. Please go to the gym. Okay. To access the lessons, please go to the gym button at the bottom of the terminal screen. Okay. Go to the gym. There we go. Now we're talking. Okay. First stripe white belt. We're going to get this on. All right, after we're learning how to navigate here, hold on. What is this? Like, I have a notification here. I mean, I'm loving this idea. I just don't know why I have a notification here. Oh, it's a daily challenge. I guess that's what it is. Hold on, I'm not gonna go try and solve that. It's been so long since I did binary exploitation. I'm not gonna try and get that. I'm not gonna try and remember what the stack size should be. Let's see. So what's a binary? It's an executable application that's been compiled from source into a machine code for a specific architecture. For this belt, all binaries will be compiled for 32-bit x86 architecture. Each architecture has its own instruction set. All right. So when a binary is launched as a process, the operating system loads that into its own virtual memory. To that process, it's its only thing that exists. Two different processes can have the same address because the addresses are virtualized to the context of the process only. Hold on, I gotta figure out to... There we go. I have to turn the music off because it's too damn loud. We'll get back with the regular stream music. In all my years of faking it to make it, I've realized there's like 30 ways to one end goal. Dude, there is, man. What do you mean? Also, what do you mean in all your years? Aren't you like 17, dude? I mean, if you are, that's awesome. You've determined that. Oh, dude, happy birthday. That's killer, man. But still, yeah, don't take this the wrong way. This is a measurement of difference in years, not in detracting your skill. You're a pup. But to learn that at such a young age is a very good thing, right? Yes, there usually are many different paths to take to get to an end goal. The important thing is realizing which paths are actually going to be fruitful, which ones are going to be painful, which ones are dead ends, and trimming those off early so you can find the fruitful ones. The painful ones might still get you there, right? But finding the fruitful ones, that's one of those things that kind of comes with experience. Like, hey, yeah, I could do this, right? Here's how we execute this large task. punching way above his weight. Now, he is far more organized at that age than I ever was. No. I think actually at 17, I had been doing martial arts training very, very heavily for about a year at that point. And that was like my big thing. I was still always into computers and messing with them, but mostly that like absorbed all of my time and effort was doing martial arts for a long time. Which is kind of why I like the idea of the binary jiu-jitsu. Dude, well, hold on. So the new video, I mentioned earlier that I had screwed up and was recording on mute earlier today. Well, it's because I finally have gotten like a workflow down. I've been working with Harvey. We've troubleshot a lot of stuff, and we finally got a workflow working where I can begin cutting YouTube videos. It's still not optimized yet. Ideally, I should be able to go through a news story like on the live stream here. And then in 4 hours is the goal. 4 hours to go record a dedicated video, edit it, optimize it for all the SEO stuff, and then publish it. That's the goal here. Currently, the first video that I just published today about the FIFA hack, that took about 10 hours. But that was also a lot of experimentation and building out some tools to help speed up the process. So you can't optimize the process from the beginning, and that was my biggest fault when I was going through this. So going through, and I'm just putting in the reps and the hours now so I can optimize the process and finding little places to tweak it. At 18, I was troubleshooting computers, but not triaging malware or threat intelligence. I know, right? That's what I'm like, bro, you're... Okay, the computer's still online. My mouse died. God, I was scared there for a second. Do I have a charging cable over here? I'm sitting here moving this. The streaming computer's on. And so I'm like, okay, the stream didn't die, but did my computer die? No, it's just that my mouse died. Crap. Hang on. Will this work? Let me see here. Stand by. I'm doing emergency cable management. Oh, there we go. Hooray. The mouse lives. Okay. God, all the technology is just driving me crazy tonight. Everything's dying, everything's breaking. Let's see. All right, so back to where we were on this before I got sidetracked again. Let me bring this up here. There we go. All right, so by the way, if y'all didn't know this, what he's talking about here is called ASLR, address space layout. Well, actually, this is different. Virtualized memory is different from ASLR. That's a different thing. But basically, every process that's on your computer, it's working off of a memory set that thinks it's its own, it's unique. So two different processes can see the same memory address as two different, completely different things, right? And everything in their memory address is set up for their own process. So that's what that's what they're talking about right here. So this allows the process to be blissfully unaware of the other processes running on the same machine. Each process has a memory map, which is a layout of what segments are where, what segments are where during runtime. And each segment has its own permissions: read, write, and execute. We're very familiar with that because we talked about the binary exploitation. But you know what? It's been so long since I did this. I'd like to go get a refresher on my fundamentals for binary exploitation. It's one of those sell PC, buy a goat kind of days. I'd rather go buy a cow. I'd like to just have some cows one day. Hold on, let me check your message here, Potion, because you had some good stuff in there. Let me see. I found troubleshooting to be pretty basic for me. I just found malware and threat intel more fun to do. I can't code, and I know that I'm not awesome at large level exploitation, but I certainly can investigate things and like to do deep dives into new things. Yeah, I mean, dude, you don't have to be the best at everything. Obviously, y'all are going to see me struggle here because, like I said, the last time I really, really dug into binary exploitation was probably about 16 years ago. So I was like, cool, doing some of this I thought would be actually really fun. I like jailbreaking, and even if I can't code, I understand what the code's doing and can read it, and that's very efficient. A lot of jailbreaking also comes in like the, the reverse engineering side of the house, right? Depending on the kind of jailbreaking you're doing. Let's see. All right, so they're talking about each of these memory segments has its own permission set. Has 3 permissions: read, write, execute. Most segments will have at most 2 of those permissions. Below are 3 of the most important segments that come to exploitation. There's a text segment, and this is the segment where the machine code actually resides. If you were to hex dump that segment, you see the bytes that represent the instructions. The byte codes can be directly mapped to assembly instructions. The permissions for the text segments are read and execute. Makes sense, because you don't want to go modifying this in memory, right? So the stack is the memory segment responsible for tracking the state of the application's functions in something called a stack frame. Variables, registers, and return values are all things that can be saved to the stack. The stack is controlled by the compiler, and everything allocated to the stack must be sized accounted for at compile time. So this is talking about statically compiled types and compiled code. So not like we do with Python, where we get very fast and loose with it. And this segment has read and write permissions. So typically you would not have read, write, and execute permissions happening on the stack here. That's why, like, a lot of times when you see malware go and allocate memory space and it's got read, write, and execute permissions, it's such a big red flag for antivirus and EDR. It's because most memory segments don't need to have execute permissions, and if they do, they don't need to have write execute permissions. Will this be a regular thing, like doing the CRTO prep? I don't know, maybe. I at least wanted to go mess around with it. It was really cool. I wanted to go check it out, especially since I know a lot of people like to go do this. So I figured tonight, tomorrow night, we'll tinker around with this a bit. We'll see how far we get. We'll hack around and find out. And then, let's see. Oh, by the way, I mentioned to y'all earlier at the stream that I'm going to be out of town Wednesday. I'll be back Thursday, so we'll do the news stream on Thursday and cover everything got in there. So if you find cool stuff, go toss it up in Discord. We've got some interesting ones up there already. I think, yeah, Pliny literally released a new research paper called Lingua Ex Machina. A procedural xenolinguistics engine reveals zero-shot language acquisition, human unreadable coding systems, and exploitable covert channels in frontier AI. I'm like, damn. So I don't know how far we're going to get through that one, but that sounds pretty freaking sick. And then also Potion was talking about some stuff from Shiny Hunter. So we've got the makings of a fun news night. Hey, Cypher, what's up, dude? We're actually over in here. Let me actually, hang on. Let me go pin this for everybody here. Actually, let me see if I can do this properly. Nope. Okay, copy paste is still busted. I gotta do it by hand. There we go. Let me pin that. Boop. We're going through the Binary Ninja Labs. There we go. Drop that link for everybody here. Oh, crap. I just remembered I forgot to do something. Hang on. Gotta drop back into OPSEC mode. Some of my stream monitors are not on. Let me go get those going. Like I said, Sock almost let me sleep, but she knew I'd been sad if I didn't actually get up for the stream because I'm going to be gone Wednesday. So she got me up to give me the option. All right, let me make sure these are running properly. Okay. Good, those are actually all working now. Nice. All right. Yeah, I'm wondering how if like we're gonna start digging into different compilers or anything. So we are starting at the very beginning for two reasons. One, if anybody else is following along, and you're like me and you haven't touched binary exploitation in over a decade, I thought maybe some refreshers of the basics might be helpful. So I was like, we're gonna start at the very beginning. Plus, you actually have to go unlock the additional levels in here. So I was like, okay, cool. Let's just going over the fundamentals is never a bad thing. I was thinking about this a while ago. We make programming languages to be human readable, and when we make language models to blunder around them, would it not be easier for machines to use more binary-ish language? It would make skills for models more compact. I think the ultimate end goal, Hats, would be to actually just have the language models go straight to assembly. If you really think about it. Either that or like a super low level language that maybe has some function safe or like some memory safety. Like think of it like a safe version of C. Anything like that, perhaps. But I don't know. Sounds pretty cool. If you want something cursed, there's TypeScript bash for agents now. What? Bro. Hang on. Getting sidetracked again here. Vercel Labs. Just Bash, a virtual bash environment with an in-memory file system written in TypeScript. Gross. And designed for AI agents. Broad support for standard Unix commands and bash syntax with optional curl, Python, and JavaScript, TypeScript, and SQLite support. Gross. I feel dirty even just looking at this repository. So basically, yeah, sandbox simulated bash that runs in memory. Yeah, there's been some examples of them trying to get language models to go directly to assembly foil, but they just haven't done a good job of it yet. Most of the reason why they do so well in things like TypeScript and Python is because those are very, very popular languages. Orders and orders and orders of magnitude more popular than assembly, right? So that's why it's so much easier to get the language models to deal with that. And that's why Anthropic has largely focused on the Bun style JavaScript ecosystem, and Python is OpenAI has largely focused on the Python side of that. Also, it tends to be like which area they're focused on. I think Anthropic is more focused on, they're trying to really target the back-end developers, and then OpenAI is really trying to target more of the front-end developers. Or maybe I had this backwards. I don't know. I had looked at it. I'm still waking up, guys. Bear with me. Brain is not braining at 100%. Yo, what's up, guy? Shellcode's an interesting thing to do with agentic models. I want to work on that some more. Especially since, what is it? Wasn't there a new Kimi model that just came out? Gemini tells you straight up it was meant for Python. I believe that. All right. Anyway, so let's go back over to what the memory segments are. So we're talking about, we have memory segments. There's three main ones here. Let's talk about text segment, which should only have read and execute permissions because it's the actual assembly code for the program. The stack is where everything is being managed for the state of the application. So there's no execute permissions, but there is read and write. And then the heap is also a memory segment that the developer has full control over. So the stack actually gets handled by the compiler. The heap is what's mostly handled by the developer. Allocation happens during runtime. Sizes are dynamic as opposed to the stack. Heap memory is allocated in chunks. Complex data structures can be created with heap allocations. The heap is generally read and write permissions only. Heap exploitation will not be covered in this belt, but it is an important segment. So we're going to keep that in mind. All right. Let's see. Challenge 1, read the map. for 50 points for Gryffindor. Let's see. Oh yeah, not sponsored by Jocko yet. I start cranking out YouTube videos again. Maybe I could get sponsored by Jocko. Maybe that was the one I was thinking of, Bobby. GLM52, the one from, that's from ZAI. Yeah. Let's see. So what are we supposed to do here? For this challenge, there's a running binary that has its own virtual memory space divided into the segments with different permissions. Each segment has a job. The text segment holds the machine code. The stack holds the local variables, and the heap holds dynamic allocations. So the binary, this binary will print its own memory map, the actual layout of its process memory. Your job is to find the segment which contains the code that will be executed and submit its starting address as the flag. Okay, that's a cool one. Cool, we got a little thing here. All right, so let's see. So if we've got all these memory ranges in here, we got one that literally says, hey, here's the heap. First thing we can look at is which is the only one with execute permissions. Well, we actually have a stack with read, write, execute, which is a little bit weird. But the only other one with execute permissions is this, but that's libc. And then let's see. Here we go. I think this is the challenge one right here. So what command did we actually run? I guess we ran the challenge here. If that's the case, it should be this memory location here. So the question is, what's the address of the executable section of the code in the binary? So these are in the shared libraries here. So this is the only one with the executable section. So we'll try this. We'll start at the beginning of the range here. Done. Good. Yeah. The SO files they're shared objects. They're kind of like the Linux equivalent to a DLL on Windows. So they're compiled, they have reusable functions in them. That's what they are. At least that's the way I've always thought about them. One of you Linux graybeards can feel free to correct me if I'm talking about it wrong. But yeah, this is basically the Linux equivalent to a DLL. Language models poop their pants proportionally to the language and system popularity, so I'm trying to get Claude to write some complex GUI ran code, or GPU ran code, plus assets in 3 languages. It's not pretty. Yeah, no kidding. Let's see. Okay, so I guess we go back to the lesson now? Oh no, we already did the lesson. So, all right, so we did this. Back to the game. Boop. Okay. I did this. Why don't I get to go to the next one? I already completed you. What do I have to do now? We didn't even have to use the hint. Nice. There's the info. Back to game. Oh, there we go. Now, finally, the reading the disassembly one opened. I don't know why it didn't take it at first. I forgot I still have a Claude sub this month for our brief encounter with Fable. Oh, poor Fable.
Bullshit, I can't hear you. Sound off like you got a pair.
Killa, I know you're lying. And I want you to know that I know. That I know you know. That you know that I know you're lying. Let's see. Shut up, baby. I know it. Got to go burn some usage. That's what I've been doing, actually. So part of the way I was going through this video process is I'm using a editor called Descript. And it's pretty cool. They had some really cool ideas, but I haven't really used it in a while. And they had even like a cool built-in AI editor. It's a little chat system. They've got their own custom tools. Essentially their own little AI agent, but it's backed by OpenAI and it's backed by Claude. So there's different providers in there that you can check. And as I'm going through and I'm working with it, I'm like, I recognize all of these text patterns that it's spitting out. I was like, this is Opus. I can tell day and night this is Opus in the back end right here. So that was kind of funny. I was going through working on that, burned a lot of my AI credits for the month because I'm on like one of the scrub tiers for Descript. However, like I said, I learned quite a bit. And there's some stuff I'm going to put in place to be able to do a lot of the upfront processing that I was having that AI system do more or less programmatically on my system. And then I'll send it up to Descript to polish it. I think I'm upgrading to the $100 Codex plan. I have access to Codex and it works really well. I don't know how much usage you get out of it because it's part of a corporate plan. So I don't have direct knowledge of the billing, but I like Codex. GPT 5.5 does a really good job on it. And actually I kind of like the Codex interface. It's not bad. It is an Electron app, so you do got to deal with that part of it. I've got so many Electron apps running on my work laptop, it just makes it cry. That's how it goes. Let's see. All right, so now let's go to the second. So we're still on our first stripe. We got to talk about reading disassembly. So assembly is the human readable version of machine code. Each instruction maps directly to machine code bytes.
Sound off like you got a pair.
You guys just spamming the sounds. Hey, Almovar, what's up, dude? Yes, my mommy did buy me a pewter for Christmas. My mommy loves me. Let's see. All right, where was I? You guys are distracting me. You're very good at that. Each instruction maps directly to machine code bytes, which means that after the source code's compiled, we can disassemble the machine code and be able to read the assembly. Most programs are written in high-level languages such as C. It's so funny to think of C being called a high-level language because when it first came out, it was the highest level language. And now it's like, there's been so many ones up there. And most people that used to deal with Python, they're like, C's dangerous. That's too low. Let's see. So that process of recovering that original source code is decompilation. So during compile time, the compile optimizes the code. So sometimes decompilation looks a bit different from the original source. For now, we're going to focus on disassembly rather than decompilation, as this will come to the source. This will be rather than decompilation, as we will be using source code for this section. Okay. So what are registers? They're very small, very fast memory cells inside the processor. They're used for math and logic operations, as well as managing the state of the binary application. So some of the common ones are your EAX. Now keep in mind, there's a whole bunch more registers. These are like the top ones they're choosing to mention at this point. There's a lot of other ones in here. And then once you get into the 64-bit architectures, there's even more in here. Registers are those things that I steal money from, right? Yes, that's right. Using Ghidra or radar to reversing? Not yet. So it's in the pinned comment, Almovar, but we're going through binary Jiu-Jitsu. And I just thought it'd be a fun thing to, it came up on the news stream. We just finished going through the Game of Active Directory Challenge Lab, Dracaris. So I was like, what am I going to do next? And then this came up during the news stream. I was like, okay, cool. Let's go check this out. This looks pretty fun. Don't use cracked versions of IDA Pro. No, that way lies dragons and malware. All right, so the typical like popular 32-bit registers are EAX, which is usually used to return a value from a function. EIP, which is the instruction pointer. It points to the next instruction that's going to get executed. And if you control that, then that's usually what you're doing. So when you did like stack overflows, stack buffer overflows, the whole goal was to gain control over EIP and point it to somewhere else in the stack where you had your malware like already set up. And then you've got ESP, which is extrasensory perception, allows you to read the computer's mind. No, that's the stack pointer, the extended stack pointer. That's what all these E's stand for. And that register points to the top of the stack. And then you have the base pointer, which points to the base of the current stack frame in here. The Minecraft Bedrock community actually makes insane cracks of IDA Pro. Dude, I don't know what it is about gamers pulling off the most epic cracks of things. It's wild, man. I'm using pointers to SHM to do this. Thousands of rusty crabs. Gasp. SHM, for everybody who doesn't know, that's shared memory. Yeah. Dude, I just dropped a video for YouTube earlier today, just a little bit before the stream started even, and it's a polished up version of what we were talking about from Bob the Hacker's blog post on the news stream, talking about how he hacked FIFA, basically. And so typically I would have waited until like Tuesday to go release that, but yeah, it was fun. It was a fun video to do. It was a good learning experience. All right, so then our basic instructions are, let's go back a little bit. Assembly is made up of instructions that execute sequentially unless control flow gets disrupted. And some of the common instructions are move, which is move data from the source to a destination position in memory. And then LEA, which is load effective address. That computes an address and stores it in a register. So for example, if we did, actually, I forgot, these are always, it's destination and then source. I wish they had kind of reworded this. That'd be like one criticism I'd have here. Because I guess it depends on the syntax. There's actually two different versions of assembly syntax that you can use. But typically it's move to here from here, right? So this would move the value 1 into the EAX register. So move to EAX the value that is either this static value or something that's referencing like a memory address. Move this thing at the memory address over to EAX. And then the load effective address loads the address of the extended base pointer plus a hex 10 value into EAX. So load into EAX whatever the base pointer is plus 10 hex, what is that? $16. There we go. My brain is really not firing. I think so. Hold on. I think you're right. Yeah, Intel. So this is Intel syntax. Thank you for reminding me, Dumas. So yeah, AT&T syntax, which is the one I used to kind of work in, had this backwards. Where AT&T syntax, it was source and then destination. This is Intel syntax, which is destination source. So they're just backwards. Why? Who knows? Let's see. So these are our kind of like our basic data moving operations in here. And then we have stack operations. So we can push, which decrements the stack pointer and writes the value to the top of the stack. So the stack kind of works like this. Flashbang. There we go. I'm probably going to screw this up because, like I said, I'm pulling this all out of memory and I haven't done this in a long time. All right. So the stack is what's called a philo. So that's first in, last out right here. Meaning that the stack, if you've got like your base memory segment here, right? The stack grows this way here. And then so once you stack something onto it, you cannot get to these other values until you pop this other stuff off the stack right here. So the first thing in is the last thing out. So that's what they're talking about with, shut up, baby, I know it. And so when you push something onto the stack, it decrements ESP. So these down here, this would be like our low memory values, and this would be our high memory values up here, right? So this over here is the stack. And then up here is actually where the heap goes. So you pile onto the heap, and it moves towards those higher memory values. And I think the heap works in the kind of, maybe it works in the philo, I forget exactly. But this is the heap up here. So the heap is actually moving towards higher memory addresses. The stack is moving towards lower. So that's why, if you think, if you keep this in mind, right? Let's say this is 0x0000, just for an example. Then up here would be like 0x f f f f, right? This is where it's growing towards here. So that's why whenever you push something onto the stack, it decrements the stack pointer. Why? Because the stack pointer is going to have to go from here to here. The stack pointer has decreased whenever you do that. And then it's going to write this thing down to here. So actually, hold on, let me back this up. So the better example is if the stack is down here and you push something onto it, right? So we push a new value here. We'll do this in orange. So you push a new value onto the stack. Now the stack pointer, because it's going towards these lower memory addresses, has to get decremented to point down to here. So that's why ESP is going to get subtracted, because it's going towards lower memory addresses. This gets loaded kind of like in some middle ground here. So I'll say like, maybe this would be, just for example, don't take my word for this. This would be like 0x, let me see, be 8, something like 8888 here. Actually, I think technically, take that back. It'd be something like 7777. This is like, just an illustration, this is like the middle of the virtual address space in here. What's that? Is that Kankles? Your name is black on a black background on the chat readout. What's up, dude? Don't play on assembly after 20 years. In the 90s and 2000s, demo scenes are cool. For the assembly, only hard path is making the little steps versus C# or Python. I know, right? Oh, that's right. So yeah, the stack down here. So let's clear this out. Let's do this. We'll make ourselves a happy little rectangle here. Clear this out right there. Do like a little bit of clearing action. There we go. All right. So the stack right here is philo. First in, last out. And then, yeah, the heap is actually LIFO. It's the opposite. Last in, first out. If I remember correctly. Is that correct? That the heap is backwards. It's a LIFO stack instead. It's a LIFO input output instead of a philo. Totally not Black Hat though. That's right. Watch this clip with an old streamer, buddy. Hang on. Let me see what it is. Hold on. Do I have the desktop audio off? Yeah, I do. Holy crap. Potion, I knew you had troll game, but that's excellent. Hang on. One sec. Hang on. This is too good. Oh, the heap is a Lilo. Last in, last out. Okay. Hang on. Let me update the diagram here. Hold on. This is too funny.
We're going to paint my face any color you choose, Potion. You can choose any color I paint my face, and I'll paint my face that color. What color should I do? No, you can't just double down. Is there any other color you want to see other than that one?
Brown.
Next stream, we're...
That's brutal. That's why you always have to be very careful with what offers you make to the chat on the stream. Oh my god. That's brutal, man. He's the first ever American YouTube Shorts creator. He quit, went to TwitchCon with like 14 followers, and did that for a bit again. Nice. Black's not a color, but brown is. Now we're getting pedantic. Yeah, paint your face in duct tape. That would be funny. No, I'm not painting my face in duct tape. All right, let's go back over to it here. You guys are funny. Engaging the public in choices is never fun. I know, right? All right, so now that we got we're digging out the cobwebs, and I've got my reimagination of how the stack works in here. This cable is driving me bananas. B-A-N-A-N-A-S. There we go. Let's see. So after we got this fixed in, so refresher, because who was it in the chat that reminded me? It was... Hold on, who was that? I saw it. Anyway, one of y'all had reminded me correctly that, yeah. So the stack is a philo in here. First in, last out. Whereas the heap is a lilo. Last in, last out. So once something comes in, it's the last thing to go out. One night he took a bite of toilet paper roll every time he took damage. Potion happened to be at his base, and it's anarchy, so I was hitting him quite a bit. Damn, dude. That's brutal. Alright, let's see here. Alright, so we had, let's recap real quick. We had our data movement operations, which was move, which moves some value over to a register, and then we've got our load effective address, which is load the effective address of, in this case, the extended base pointer plus an offset over to the EAX register. We have to remember that this is destination source, so we're moving to this from this, basically. So for our stack operations, we have what we talked about here. We have push and pop. Push, because it's growing towards the lower address spaces, has to decrement the ESP register to keep the stack pointer aligned properly. And then pop has to actually increment it, because it also works in reverse. If we pop this off, right, then we've got to go backwards. We're going to go towards those higher address spaces in here. And then we have very basic arithmetic operations. So, for example, we can subtract. So in this case, this would subtract 40, 0x40 from the stack pointer, which in this case is 64. So it subtracts 64 bytes from ESP, commonly seen for variable allocations, and then you can also add to it. So like we could increment EAX by 1. So this will take this value and do the arithmetic operation from the source to the destination. And so it's going to modify that destination address. So unlike when we're doing things in higher level languages where we say the variable is now equal to this thing, we now say, hey, by the way, the variable itself is actually going to get modified when you do this. Stacks remind me of a book. Fourth book. Hold on, what was the fourth book again, Hats? Because I'm blanking on it. Let's see. And then we have a couple of other control flow ones. This is a very good refresher, because like I said, it's been about 16 years, 15 years-ish, depending on what time of year it was, that I've done binary exploitation. So this is a very, very good refresher. I like it. Oh, you know what? Let me see if I can do something real quick. Can I pin this over on... Oh, I can. Hold on. So over on YouTube, guys, I just pinned that message too, because I didn't realize I could do pinned messages on YouTube. So that one is pinned up there as well for the lab that we're going through. Did that email ever come through? No. I'm going to email them and complain. Can I speak to the gym's manager? All right. Let's see. All right. For control flow, call is push the return address to the stack and jump to the function address. And then we have return, which is pop the address from the stack into the extended pointer, into the instruction pointer, and jump there. And then we have, let's see. We have our jump, which is an unconditional jump to an address. We have a compare, which compares two values, sets flags in the flags register. Different flag. Shut up, baby, I know it. And then we have a jump if equal and jump if not equal here. Checks that the flags in the registers to determine what to do. So for example, if we compare EAX to 1, then if EAX is 1, then we'll jump here. Jump if equal, we're going to jump to this address. And then we're going to call whatever our vulnerable function is, and then we'll return after that. So yeah, that's what we're doing here. Let's see. Yeah, if EAX is 1, jump past the call straight to the return function. Oh, sorry, actually, I did this incorrectly. Let me play this back. So we're going to compare, does EAX contain a value of 0x1, the value number 1, right? If it does, then jump past this call straight to the return here. So basically jump over this call to the return if those values are equal. If they're not equal, then call the vulnerable function. So this is how this is working. So jump if equal says basically jump over the next instruction if they're not equal in here. So let's talk about reading functions in here. So we've already covered function prologues and epilogues, but there are a few things to discuss about the anatomy of a function that goes beyond the scope of a setup and a teardown. So when reading assembly, we need to understand how those local variables actually look. So in C, we may see something like an integer var is equal to 10. In assembly, it looks very different, which is we might say that we're going to move to the base pointer, right? We're going to move onto the stack. We're going to drop down 4 bytes, and then we're going to write 0xa, which would be a 10, right? So what we've done is we have written where this variable lives on the stack when we did this, right? So the application makes space on the stack during the prologue. This space is for those local variables. Each variable takes up a specific amount of space based on the data type. In this case, it's a 4-byte integer. That's what this is. Yeah, so we have a 4-byte integer. So chars are typically 1 byte, shorts are typically 2 bytes, integers are 4 bytes, and then we can have a char buffer, and whatever size we set it to, it's going to be that number of bytes in here. So if you have a different sized buffer, I think it's going to, like if you have a variably allocated buffer, it's going to throw it up on the heap as opposed to on the stack, if I remember correctly. All right, now it says, let's see, identifying the arguments. So remember how function arguments are loaded onto the stack in reverse order. So when a function is called, it has to retrieve the parameters from the stack. So what they're saying is, if we come here, right, and we're looking at our stack diagram, and we come down here, this would actually be, because they're loaded in reverse order here, right? This would be this would be like var 1, right? And then this would be like, let me back that up, var 2. This one right here would be like variable 3, and then this one right here would be like variable 4, right? So they get loaded in reverse order because of the way it has to load them into the stack. If I think I remember this correctly. Yeah, so here's the second argument. Here's the first argument. And then actually, yeah, there's another part that goes down here, which is going to be the last thing that actually comes onto the stack, which is going to be the function's return address down here. Boop, just like this. So if we look at it, argument 2 gets loaded at the base pointer plus a C offset. C is greater than 8, right? So it's higher up in memory. And then here, the base pointer is 8. So yeah, they get loaded in reverse here. So we have our return address, then we have the saved base pointer, and then all of our local variables right there. Bam. Okay. So the common pattern you'll see for arguments being read from the stack looks like this. For C, we'd see like example function integer A, integer B. But in assembly, this looks like we're moving parameter A to a lower portion of the stack, and then we're moving parameter B down to a higher portion of the stack, right here. So that's the main thing to remember here, is that they get loaded in reverse order on the stack here. So this was correct. The last variable gets loaded, and then the second to last, and then finally you load the first variable into here. Man, I haven't done assembly in so long. It's fun right now because we're back in like the easy stuff that I can just dig out of very long-term cold storage. So the key takeaway here is the assembly is a human readable representation. The registers are small, fast storage cells. EIP is the big one that controls execution. And ESP and EBP manage where the stack is pointing in here. Right? So this is the... God, correct me if I'm wrong. I believe ESP basically points to this address right here. And then EBP would point to wherever it is down here. I believe that's correct. Wish I just had a memory diagram. Yeah, I thought that was the book you were talking about, Hats. The fourth book with the spicy looking lady and the, what's it, the He-Man looking guy on the cover. Let's see if I can find it. I guess it's being filtered out of the image results. Let's see. What was the fourth language programming book with the chick on the cover? I think this is it. Hold on, let me see if I can find this one. Yeah, I remember you sending this to me one time. Is that the one? That's not it. He got yeeted from the web. No, I know there's pictures of it around. Damn, that was funny too. Someone did clean up. Nothing's ever truly gone off the internet though. Let's see. Oh, actually, I take it back. I had the diagram incorrectly. So the local variables all live at a negative EBP offset. Arguments live at a positive EBP offset. So no, I did have this correctly, yeah. So, well, this is actually a little bit incorrect. So these are all, like, actually, yeah, these are our functions, right? So here's EBP, and as we push stuff into here, it should be like this. Hold on. Make sure I got this correct. The local variables all live at a negative EBP offset. Arguments live at a positive EBP offset. Yeah. I think that diagram was correct. If you find it, let me know because I'm going to save it. AI says the book cover never existed. I was just checking with Grok, actually. I'm telling Grok, like, I have absolutely seen this book. Look Harder also had a big-ass He-Man looking dude on it. Hang on, I Okay, hold on. Well, Grok's looking for that. Let's take a look at this. So for this one is, go read the assembly. What's the value of EAX after the return instruction is executed? Okay. We're gonna find it. Yeah, even Grok won't go find it. I know it exists. I should have saved it, just because it's hilarious. All right, so let's go see where this is. So we're going to push our extended base pointer. So the question is, what's the value of EAX after the return execution happens here? All right, so let's see here. Do we operate on EAX? So we move 5 over to EAX, and then we add the EBP minus 0x4. Ah, here we go. Okay. So let's take a look at what's happening here. So our first interaction with EAX, this essentially wipes it. This sets EAX to 0x5. Hold on. Let's do this. We'll switch over to programming right here. Let's see. So that sets EAX to 0x5. So we're going to have 0x5. And then what we're going to do is we're going to subtract the base pointer minus 0x4. But up here, we had a move operation where we moved, let's see, 0xa over to EBP minus 0x4. So we're going to add these two values together. We're going to add 0x5 and 0xa. So then we'll do plus 0. Let's see, plus an a. Damn it, it did a minus instead of a plus. So yeah, we should have an F in there now. So after we add these together, we don't do any other operation on EAX, so answer should be F. Correct. I mean, that wasn't that bad, because that was a very tiny function right there. Hey, Kaiju, what's up, man? We're working on a system called Binary Jiu-Jitsu. It came up during the news stream Wednesday night, so I thought, hey, we just finished Dracarys. Let's go run through this. It's pinned over in the chat on Twitch and on YouTube. I hate that everything does not index network drives. Pretty much. All right, so if we go back here, loading the gym. All right, cool. We got through our reading disassembly. Nice. Let's see here. Now we're going into the stack. Basics of the stack. Then we'll go heap diving some more. Let's see. So the stack is a phyllo, which is first in, last out data structure. So think of the stack like a stack of pancakes. An empty stack, then a stack, then a pancakeless plate. And as we add pancakes, we stack them on top of each other. So if we want to access pancakes on the stack, we first need to remove the ones on top. That's not how I eat pancakes, but I'll go with the analogy. So adding a pancake to the stack is done with a push operation. So when we push something onto the stack, we're adding items at the top of the stack, which is really at the bottom of the memory addresses. When we remove a pancake, it's called a pop. So popping a value from the stack removes it from the top, which is weird because the top of the stack is actually, like I said, down here at the low memory addresses, right? There we go. So yeah, down here at the low memory addresses is where we're doing that. Everything's the best file search tool for Windows. Super fast, uses its own index, but indexes only local drives. Oh, I got you. Yeah, it's really sad whenever you have to go make your own file indexer because your operating system sucks. Thank you, Microslop. So here's how actually, yeah, here we go. This is how our stack looks. We have our high addresses, which is up where like the center of the core of the program is. And then we have our first pancake, second pancake, third pancake, fourth pancake, and then low addresses down there. So it's adding them down towards the low addresses. So the memory region called the stack is a stack data structure where Linux processes save program states through push and pop operations. This region of memory is great interest to us and where we'll spend the rest of our belt focused on examining closely. Okay. So the key takeaway, stack is a Philo data structure. Push and pop operations are how we interact with it. Question. So describe what the student needs to implement. The input is describe the input format. Output is describe the expected output. Okay. So what concepts of the lessons do we already apply? All right. So the question is, you push the values 10, 20, 30, 40 onto the stack. Then you pop twice. What value is at the top of the stack? Okay, so we've pushed this one, and then this one, and then this one, and then this one. And then we've popped off 40, we've popped off 30. So now 20 is going to be at the top of the stack right here. If I missed that one, you guys would heckle me endlessly. Microsoft's so lazy, they can't even steal a file indexer from OS X for 30 years. I know, Windows file indexing is absolutely atrocious. All right, so let's look at where the stack, let's see if I remembered correctly, where the stack and the base pointer registers actually happen. So the base pointer and the stack pointer actually work. So there's two important registers that contain pointers on the stack, ESP and EBP. So these registers are used to track the current state of the stack's contents. So ESP is the stack pointer register. This pointer is at the top of the stack. Push and pop operations have a direct impact on the stack pointer. So whenever a push happens, ESP gets adjusted to point 4 bytes below its current value. When pops happen, the address is adjusted 4 bytes higher. Is it always 4 bytes? I guess so, because... Well, yeah, because it's 32 bits. So yeah, it's 4 bytes. So that's important to remember. So in 32-bit architectures, ESP always moves in 4 chunk increments. Whenever you push something to the stack, it's going to be decremented by 4 bytes because we're going to grow this way towards lower address spaces. When we pop something, it's going to increment by 4 bytes every time because we're going to go up the memory address space. All right, so for the base pointer, though, it points to the bottom or base of the stack frame. So push and pop operations don't change the base pointer. So yeah, I did have this right. Nope, I didn't. I had it completely backwards. Hang on. It's okay. Hey, don't look at any of this. You saw nothing. There we go. No, stop it. You saw nothing. Damn it. You saw nothing. There we go. Okay, so I had this backwards right here. This is the ESP right here. This is the base pointer right here. EBP points right there. Boom. By the way, what'd you do with your Hermes agent? I'm actually going through and customizing it right now. And then some of the stuff I was working on to customize it, then I saw the guys over at Hermes. I haven't even fired it up yet. I've just been tinkering with the code and looking at it. But then I realized that they finally did like what they called the clean slate version, I think. I think that's what the message they just sent, guy. And where you can start it completely fresh and blank. I was like, damn it, that's kind of what I wanted. So some of the work I was just doing, they've already taken care of. So it's just a tiny little side project I'm working on. I'm basically giving it the personality of Dixie Flatline from Neuromancer. Except I had to make it a little bit more user-friendly, because if it was really in the real personality of Dixie Flatline, it would not be a helpful AI agent. I'm going to rebuild mine with the clean slate version. Yeah, I want to go tinker with it. Currently, it's hooked up to Codex. That's where I'm messing with it. But I'm adding some additional features to it. And that's what I was doing with it, guy. Tinkering around with it. Making a few small code changes, but now I got to go pull the new codes that they just pushed. All right, so the key takeaway here is the two registers that track everything are ESP and EBP, the stack pointer and the base pointer. ESP tracks the top of the stack, which is actually the low memory address. EBP tracks the top of the stack. I'm sorry, EBP tracks the bottom of the stack frame. That's right, we have stack frames in here, don't we? Hold on, let's see what the question is. Let's see, you push 3 values onto the stack. ESP starts at FFFD060. What is ESP now? So if you push 3 things onto the stack, you're going to be decrementing it by 12, which is going to be, let's see, A, B, C. Hold on. Yeah, A is 10, and then B, be 11. C would be 12. Okay. So yeah, we're going to decrement it by, or we're going to basically decrease it by C in here. And then that's going to bring us down to, I don't know what. Calculator. That's what it's going to bring us down to. Do that minus a C. There we go. So that's going to bring us down to D054. FFF D054. Incorrect. What? ESP started at D060. You push 3 values onto the stack. Yeah, I got C. So then we have FFF D060 minus C. Did I not have it like in the correct format? Surely I did. D054. Maybe I typed it in wrong? D054. There we go. I must have fat fingered it somewhere. Clipped it. Yeah, you can clip me doing my horrible hex math. 57, which I never have to do. Ever. You'll have to ask my colleague to leave it in some corpo server room during a pen test later and break it out for fun to maintain the immersion. That would be funny. I'm still in the process of reading Neuromancer. I finally decided to go back and revisit like the original cyberpunk stuff, and it's been very enlightening because I didn't realize how much stuff really originated from Gibson. And it's been really cool. I think I'm about a third of the way through the book. I'm not reading it very fast. I'm reading it just a little bit at night before I crash out for the evening. White belt stripe 1 test. Begin. Challenge question 1, 50 points. All right. Which register points to the base of the current stack frame? That would be the extended base pointer. Sensei! Awesome. All right. Question 2. Which register controls what instruction executes next? The extended instruction pointer. Sensei! There is no mercy in this dojo! Alright, last thing. What does the ret instruction do? Pushes EIP to the stack. Pops a stack value into EIP and decrements ESP. Pushes an EIP to the stack and increases ESP. I would like some increased ESP. Pops a stack value into EIP. Decrements ESP. It should be decrements a stack value into EIP and decrements ESP. No, increments ESP. It's got to grow up towards the higher addresses. No, it's pushes. Damn it. It's pops. Damn it. Can we have some mercy in this dojo? Damn it. I have to read more carefully. Gibson's pretty much 90% of everything we have now in terms of concepts, or for terms and concepts in both sci-fi and existing already. The Sprawl's the OG source. That's why I really wanted to go back and read it. So my recommendation, one of my buddies warned me, hey, if you go back and you start reading the Sprawl stuff, especially Neuromancer, he said it's not going to make a lot of sense the first time you read it, but the second time you read it, it will. And I had a different opinion on that because as I was doing some checking up, I went through and I read the 3 short stories that feed into the Sprawl series in the Burning Chrome little collection of short stories. So there's Johnny Mnemonics in there. There's something Rose Hotel, I forget. And then Burning Chrome itself, which is a short story inside the compendium Burning Chrome. Yeah. So I read those first hats, and then now I'm reading Neuromancer, and I don't feel like I'm having trouble tracking what's actually happening in Neuromancer. I think those 3 short stories really did lay a good foundation, because during those 3 short stories, I'm like, what the hell is going on? I kind of got the idea of it, but he just throws you into the world and assumes you know what's going on. And now I'm like, okay, I'm very familiar with that feeling now. And you just kind of learn how to go along with it. Just, rip it for the ride. And so now that I'm in Neuromancer, I don't have that kind of disorientation. So yeah, I've got all 3 books. I'm currently in Neuromancer, and then I'll read Count Zero. And then Mona Lisa Overdrive, I'm really looking forward to, just because I've heard that song so many times. And I had no idea where the reference was. So man, Gibson was a visionary too. Like he's looking at the stuff that he's come up with. I'm like, holy crap. Hold on, when was that written? Let's see. When was Neuromancer written? That was incorrect. I said, what was Neuromancer written? Published in 1984. Dude. That book was published the year I was born. That song's a banger. I definitely want to read the Sprawl trilogy. Dude, so Bobby, my recommendation is go read, hold on. Let me get the exact names. What short stories feed into the Sprawl trilogy? The Sprawl trilogy. I know one of it's Burning Chrome. There's a lot of short stories in there that like I did not read because they're almost more like Twilight Zone than anything I was expecting from Gibson, like for like cyberpunk. All right. So Johnny Mnemonic, New Rose Hotel, that's the one, and Burning Chrome. Read those 3 short stories first, Bobby. Read them in that order. Johnny Mnemonic, New Rose Hotel, and then Burning Chrome. And I believe that's the order they're in the compendium. Read those 3 first, and I feel like it set me up really well for for Neuromancer. Maybe I'll read Altered Carbon after this, because I've been wanting to read that series too. It sounded kind of interesting. All right, we have passed. We are now white belt with 1 stripe. Let's go look at stripe 2. I really like this learning format, actually. I think it's pretty good. All right, so now how do function calls work in 32-bit? And so if you're wondering why they're talking about stuff in 32-bit, it's because 64-bit is essentially an overlay onto 32-bit. And it introduces a whole slew of new problems in there, especially when you're doing binary exploitation and like how you have to massage certain values. Because, for example, if you're doing 32-bit binary exploitation over a network, you can't send null bytes over the network. It registers them as like a discontinuation in the data stream. So that's not really a problem so much in 32-bit, but it's a huge problem in 64-bit. So that's why you have to start back with the 32-bit stuff and then move into the 64-bit stuff. I think at one point, Microsoft even had a plan to make like a 128-bit operating system. But I was like, dude, can we get 64-bit working first? That'd be great. Because I think 64-bit still didn't have wide adoption at the time. They're like, maybe we should think about this. All right, so how do function calls work now? So when we look at a function call in a C or a similar compiled language, a lot of the details are abstracted away from us. So for example, if we have a void function that just prints hello world, and then we call that from main, we can see how main calls the function, but what happens under the hood when things are compiled into machine code. So what we have is we have main here, where it pushes onto the base pointer, moves stuff around, calls function, which is basically saying, hey, call the address here, jump to it, go to it. And then we see that we have, we push onto the base pointer, and then we move the base pointer to the stack pointer. And then we have our move of this string value, this hex value, which basically is the address of where the hello world string lives, right? So this hello world string would get basically abstracted out by the compiler, stuck into the stack, if I remember correctly. and then we have a reference to that address. So we're going to move that to the address. Then we're going to do a printf function. I don't know what leave is here. They haven't explained it yet. And then we're going to return back. Boom. So whenever we return, it should pop the return address off the stack and then decrement ESP, increment ESP. It'll increment the stack pointer because it's going to go up towards the higher addresses. And then it will execute that. Bam. Okay. So it's important to note that instructions are executed sequentially, but if you notice, the call instruction causes the program to jump to some other address. So what the call instruction does is two things. It pushes a return address onto the stack. We need that. And it jumps to the address of the function being called. So remember, if it's going to do a push, right? It's going to do a push. It's going to drop it down here, and then it's going to increment ESP and basically decrement ESP and move it down here. Boop, just like that. So the return address, the call pushes to the stack is the address of the instruction directly underneath that call. Yeah. Altered Carbon's also on my list of things to read, and Snow Crash. Snow Crash is supposed to be about finding the source to reality kind of thing as far as I know, but I evade the intel on purpose. Yeah, I understand that. I don't know, and I've heard of Snow Crash, but I don't know anything about it. Altered Carbon, only thing I know about it is what was on Netflix. All right, so the two key takeaways here is the call instruction pushes the return address onto the stack, and it's going to push the address that's directly below it. So when it returns, it's executing, it calls, it jumps to a different part of memory, and then when it returns, it doesn't return right back here because then it would just go in a loop. It actually pushes onto the stack the address below it right there. So then it picks up right where it left off. So that's why when we call, we do stuff, we call, we jump up here, we do stuff. The return address is going to be down here in this move function, this move operation. I got to make sure I don't use the word function here because it has a different connotation. It's going to return down to this move operation, then pick up right there. So the call instruction jumps execution to the address of the function being called. So this is an abstract address in memory up here, but we can reference it in the Intel syntax by name. All right, so what's the call challenge? Let's see. Building challenge containers. Oh, yeah. So run the binary and examine the address as printed. Use what you learn about the call instruction to answer the question. Okay. Hang on one sec, guys, because I think my Sock and I were watching our friend's infant today because they needed to go out of town up to Oklahoma for a real quick trip. I think I just heard them. Let me go check on them real quick, and I think Peaches needs to go outside too. So give me like 3 minutes, guys. I'll be right back. All right, I'm back. I'm back. No, I wasn't pooping. No. I know in the be right back screen it doesn't show the exclamation point commands, but I see them. Everybody else sees them. All right, let's see. All right, so the challenge here is hopping back into this binary jiu-jitsu. Run the binary and examine the address printed. Use what you learned about the call stack to answer the question. Cool. Give me the deets. Let's see. All right, cool. We're actually given some source code here. So our target function here is inside the target function. So it's going to print the address of main here. It's going to point that, and then we're going to do the address of the target function. And then main is about to call the target function. It calls it, and then we're going to return from the target function. So the first question is, what address does the call function push to the stack? Okay. I think actually we might be able to see this in the decompiler. Or do I need to run it first? No such container. What? Oh wait, why did it move it? That's I wonder what happened there. That's weird. I wonder why that disconnected in there. Damn it. These cables are driving me nuts. I wish I had noticed that the mouse was running out of power earlier today and I could have charged it. Well, so here's the source code. It says it's running. Let me reset it real quick. Okay, start challenge. I wonder if the blinky light means it's still loading. There we go. All right. I want to give it just a second here because I don't know how quickly it loads up. And I'm not going to complain because they've got the whole thing on here for free.
Bullshit, I can't hear you. Sound off like you got a pair.
Gumby, you actually had me worried for a second because when I first started the stream, the microphone was muted. And then that made me realize that I was recording part of stuff for another YouTube video earlier today, and the microphone was muted for that. So I had 800 megs of video that were just silence. Hello, darkness, my old friend. What are we working on? And by the way, the proper term is chicken lover. We're going through, it's pinned up in the chat there. We're looking at the binary jiu-jitsu stuff that we saw on the Wednesday night stream. I just thought it'd be something fun to do for tonight and tomorrow. I don't know if we'll continue on with it. So far, I'm actually liking it because I haven't...
You tried turning it off and on again.
Yes, I did. We just did with the reset button. I haven't done binary exploitation in probably like 15 years. And I didn't get super, super deep into it. I kind of tapped out at what's called secure exception handler exploits, which is not too far beyond, like basically stack buffer overflows, right? So I wanted to see how far this really goes. On the phone camera and can't see. It's, it's just called binaryjujitsu.com. That's it. It's free to play. It's a cool little setup too. I like these guys. This is awesome. All right, let's see if the decompiler actually loads this time. Hey, there we go. Cool. What did the terminal actually render for us? Hey, here we go. All right, so the question we want to answer is, what address does the call target function push to the stack? Okay, so let's go look at that real quick. So we look at the decompiler here, right? Let's see. So what we're looking for is right here. So when we invoke this function inside of main, it's going to have a call function in it, right? So if we look at back at the lesson here, notice this, it calls function, But the call thing here actually says it pushes a return address to the stack, and then it jumps to the address here. The push that it does is actually going to be the address after it. So let's go double check that real quick. So if we look in the decompiler, this is the first call function. Actually, that's the set vbuff. So there should be another one down here. There's our printf. Right, so we have set vbuff, printf, printf, printf. So we're looking for the 1, 2, 3, 4, 5th call function down here. Let's see, all these are in standardo. Let's see, where we want to look for this. So here's a printf, right? Oh, here we go. Target function. So it's going to call debug target function right here. So the return address that it should put in should actually be this one right here. Can I copy that? There we go. Because it should return after that. Because the question is, what address does the call function push onto the stack? Correct, yeah. So since this is the one that's calling our target function, we don't want to come back to this because, like I said, then we'll be stuck in a loop like that. We want to call this one because when it returns, we want to pick up where that function execution left off and come back over to it. All right, what address does execution jump? What address does execution jump to when the target function runs here? So it should jump to, let me see. Here's our decompiler. Hold on. Actually, hold on. The terminal will tell us right here. There we go. So it should jump to that address right there. Copy that. Because it's going to jump to the address where that target function is. Boop, boop. Got it. Hey, Brundlefly, thanks for coming online, man. Welcome in. I love that dial-up sound. Continue, continue. There we go. This is actually a really cool... This is a cool platform. I gusta. We already did the challenge, though. Back to game. There we go. Sometimes it takes it a second, or we have to like pop back into the challenge and pop back out for it to realize that, yeah, it did actually work. So, awesome. All right, so let's look at how the return instruction actually works. I would have killed for this when I was going through the OSCP back in 2010, which is why I had to learn the basics of like stack buffer overflows. I guess maybe it's more the nostalgia side of me that's like, I'm kind of sad they took that out of the exam. But for the most part, I never have to do this. It's binary exploitation has grown to such a specialty that it's kind of self-selected down to a small group of people that are doing binary exploitation. Small being relative to the general population, right? Heck, I dare say there's probably... Nah, probably not. I was thinking like, I was trying to compare it to like math, because that's, you know, one of my favorite fields. But I think there's probably fewer math PhDs than there are like reverse engineers that are doing this. It's a little bit more accessible. Let's see. Like IoT hacking, etc. Yeah, a lot of the guys that are doing IoT stuff, they're going to be pretty familiar with this kind of thing. Even then, though, they're not doing some of this because a lot of times those IoT systems are just running usually some flavor of Linux, and they've got a firmware package that contains an entire file system in it. So usually what they're concerned about most of the time is, can they get the firmware off and unpack it and see what's in the file system in there? Binary exploits are more for embedded things nowadays. Yeah. They noticed it before I did. Bobby's like, oh, wild tea appears. I told you, she's stealthy. Like my wife just brought me a cup of tea in my little, I don't know what these are. What are these on the cup?
Aren't they like hedgehogs? Or...
I guess they're like hedgehogs. Since the Star Wars mug broke. Yeah, they're little Sonics. That's what they are. Sock is a legend. I don't know what I did to convince her to put up with me, but man, I must have. That's the greatest social engineering achievement of my entire life.
We're gonna have to agree to disagree.
Sorry, I can't hear you. I'm on stream. She thinks she tricked me. I'm pretty sure I tricked her. And we cannot come to terms.
Bullshit, I can't hear you. Sound off like you got a pair.
That was actually really good timing, Kill. I'm gonna just keep that on my phone now. Whenever she tells me something like that, I'm just gonna. I'm gonna have a soundboard on standby on my phone, and she's gonna say something. I'm just gonna. Because half of the relationship, anytime like when you lived with somebody for a long time, half the relationship is just yelling "what" from across the house because they're speaking in what they think is a volume loud enough, but it never carries far enough. When's there going to be a cooking special? Dude, our cooking is actually fairly basic. I mean, maybe if we hit some big milestone. So the big push now is to start growing the YouTube channel. And maybe if the YouTube channel hits some big milestone, maybe if it hits like 31,337 followers, right? Will be elite status then. And maybe when it hits that mark, I'll do like a special cooking stream with Sock. Or I'll have her show y'all how to make sourdough. That's one thing she really does. She makes bread with sourdough. Really, the cooking stream would largely amount to, here's how you cook ground beef. Here's how you smoke ribs and brisket. It would typically be about it.
I do some really good desserts.
There you go. You want to do a dessert on stream someday? She's so shy too. That planet. I could mess up some sourdough right about now. She makes amazing sourdough, especially when she knows like she's so sweet too. Like so, whenever I'm like, babe, make it extra sour. Put some extra stank on it. She'll let it really ferment for a long time. And it gets extra sour. Sourdough is both amazing and dangerous. So, gentlemen, if your significant other ever says they want to do sourdough, just know you're on a very slippery slope because the next thing after sourdough is chickens. And then after chickens, you're like, well, heck, now now I'm subject to chicken math. Ooh, sourdough. She brought me some. But then after chicken math, you're not familiar with what that is. Chicken math is kind of like girl math where you don't know what happens, but all of a sudden you have way more chickens than you intended. And then after you've got all the chickens, you're like, well, crap, now I need some ducks. I got to have ducks to protect the chickens. Actually, ducks kind of suck at that, but they make yummy eggs. So we're going to get some geese now because the geese are actually assholes and will protect the flock. They're giant jerks. And then you don't want the geese to be lonely, so now you got to get some goats. And the next thing you know, you're the hookup for eggs for everybody in your town. It's a very slippery slope. All right. Anyway, back to the binary exploitation. The story of my wife. Or my friend's wife. Nice. Dude, I'm not that far away, man. Oh, I'm about this close to like, give me 20 acres of raw land for a double wide and Starlink. I'm like this freaking close. Hey, Peaches. Do you need to go outside? Why couldn't you have asked earlier? God, what a pain. Hang on one sec, guys. Let me throw Peaches outside. Not literally, figuratively. Be right back. All right, I'm back. Guess who's back? Back again. Blaise is back. Not on camera. Cause I'm gonna eat the sourdough. Don't want to eat on camera because it feels weird. It's not a magic poop. No, I was not pooping. All right. I had to get a little placeholder down here. I have a little anime chibi Blaise. Hang on. So I can find it real quick. Yeah, let me show you all this. I had to just put that in. Make that my placeholder down there when the camera's off. Just put a little anime chibi Blaise. Should animate it. I don't know if I could ever do the VTuber thing. I don't know. I feel like you have to have extra personality to do the VTuber, and I just have one. I don't have additional spare personalities. Be a PNG tuber. I could probably do that. Although I'll tell you what, speaking of VTubers, I'm hoping that something like Claude Code and Codex actually go eat the ever-loving ass out of all the VTube scalpers, like the people that are that charge a huge amount of money to go make a lot of the software and stuff. I hope that it absolutely destroys them, because it's like some of those VTubers, they're talking like they pay like 15 to 20 grand for their VTuber setup. I'm like, that is insane. Yeah, no spare personalities, no. I'll add that to the list, though. When I'm off camera, I'll add in PNG Blaise. Damn, this sourdough is amazing. I've noticed VTubers usually have 2 extra personalities, and they usually have bouncing physics, too. That's right. Yeah, the bouncing physics is another 5K. That's a DLC. Damn, I'm going to be up late after this, too. So we'll run the stream a little bit long. We're going to go for like another hour because I started the stream late. And so the sourdough and the tea are going to help fuel me for that, because after we get done, I'm going to go record the next video. I'm trying to get onto a consistent schedule where I can drop videos every Tuesday. And I'm going to be out of town next Tuesday. So I picked a really freaking great time to start doing that. But you know what? We're committed. We're going to crush it. Full fucking send. A lot of that work is usually the artist's work, I believe, based on the models. Okay, if it's going to the artist and like they're doing it, I'm cool with that. There were some shops that were charging for like that kind of stuff, and like doing if it's going to like actually doing the art and the rigging, I'm pretty cool with that, because that's a very like well-learned skill. Minecraft Bedrock was written in C++ and encrypted, and they want you to somehow do native mods and offset changes. Oh, the offsets change every update. Oh, damn. Why would they do that? Why do that? All right, I'm almost done with my bread. Oh, they do it because it helps against the cheaters? Gotcha. But dude, going through and updating those offsets has to be an absolute nightmare. Because then imagine every small sub update, when they recompile that damn thing, is going to break your mods. All right, finish my bread. I'm all carved up now. I'm all hopped up on Mountain Dew. What is this, Bobby? Oh yeah, I did see this. Yeah. Yeah, I did see this. I think you may have sent it to me earlier. Someone built a Cloud Code plugin that refuses to work until you do push-ups or squats. It's called Workout Gate, and it's exactly as cursed as it sounds. So when the hook fires, it blocks your prompt, opens your webcam, and makes you exercise to keep coding. Counts your reps live through the webcam via media pipe. No honor system rounding down. Only releases your prompt once you actually finish the reps. Quit halfway and the leftover reps get saved as debt for your next session. Chilled demo and hardcore presets, plus prompt-based, time-based, or random triggers. Tracks stats, streaks, and personal records right in the Cloud Code status line. Now, I wonder, why was he grabbing his junk while he was doing the squats? Maybe rich while I do absolutely nothing. All right, knock out 6 squats. Look at that. I was like, bro's just holding his twig and berries there. Some people just have too much time. Absolutely, Hat. Some people have a lot of time. But one of the things I do actually enjoy about all the AI stuff is the things that, like, imagine if you wanted to go make something like this. So just the time to tinker has dropped so much in there. That's so funny. Did you enjoy Fable 5? It's gone. That was my joke whenever they crapped out on Fable 5. It's like, how would I know? I couldn't do any work with it anyway. Like, I couldn't do jack with it. I wanted to try it. But like every prompt I sent, it was like, you've been downgraded to Opus 4.8. Why? Because you mentioned a hex digit, and hex is for hackers. Speaking of hex, let's go look at this. So returning from a function call. So the return instruction is an instruction responsible for returning code execution back to the caller of the function. Yes. So notice the ret instruction in the function below. This instruction will turn us back to main. So this ret right here is actually going to map to the address here. So we call it, but if we return, like I said, if we returned back to the same address where the call function was, we just get stuck in a loop. So it actually goes to the next address in there. So the return instruction pops the saved return address from the call instruction off the stack into the EIP register. So that control gets passed to the function up here. So it's passing it through EIP. Let's see. That's it? That was a very short section. Wait, didn't we already do this one? Am I thinking of something different? Oh, no. Okay, this is a different one. Because now we've got Func A and we got Func B. We've got the funk. Gotta have that funk. There we go. All right, question. Which register does ret put into the hold on, which register does the ret operation put the return register into? Ret puts it into EIP. So after the ret executes in function A, what function does execution continue in? Let's go check the code here. Let's see. So we call function A, boop. We call function B, boop. So it should continue in main. Yeah. And then which instruction originally pushed the return address that ret pops? Which instruction originally pushed that return? Well, main did. Main pushed its own return address onto the stack. Am I misunderstanding this? Which instruction originally pushed the return address that ret pops? Did they mean call? Okay. See, this is what that's why I'll take a little bit. Oh, sorry. I read it like an idiot. It did say what instruction. I read it as which function. Okay. Yeah, that screwed me up. Yeah, hex is for hackers. That's right. No soup for you. 1 year. No hex for you. After the rot execute gets flagged by Minecraft AnyCheat because your rotation was too humanistic. Yeah. Let's see. All right, question number 4 here. What happens to the stack pointer when ret executes? So if we go look at our diagram again, right? So we're pushing those ret addresses in here, right? So then we pop them off. ESP is going to be incremented because we're going to go towards, it's going to basically shrink the stack towards a higher address space this way. This is the higher way here. So ESP is going to be, the value is increments by 4.
Hey.
Hang on, guys. My friends just got here to pick up their baby. Let me say hi to them real fast. I'm her godmother anyway, I think. Am I the godmother
You're
for that
not the
one?
godfather.
No,
God-
I'm not the. I'm never the godmother. No, I'm not the godfather either for that one. I am for some of her kids. I just don't remember which ones. I should probably sort that out. Anyway, give me like 5 seconds, guys. Be right back. All right, I'm back. I'm back. That is one of my very best friends, and that was his wife. And so they asked, could you take care of their youngest daughter who's 9 months old, I think. She's little, anyway. And she's a cutie pie, bald as a cue ball, but a cutie pie. Hey, Dirk, what's up, man? Yeah, we're doing the binary jiu-jitsu labs. We came across it on continue. There he goes. We're doing came across this on the Wednesday night news stream. I was like, dude, let's go through this. This looks pretty fun. Let me see. Hold on. Everything's all kachankered now. I have no idea what this bro is cooking thing is. I must be too old now. Potion. Just gotta admit. Oh, that was a guy accidentally selling his rat. Oh, no. That's funny. Read what he's editing. Oh, hold on. I didn't pay close enough attention. Hang on. What? Hold on, let's bring this up to the big monitor. Enhance. Editing PayPalStealer.java. Bro. You cooked, son? What is bro cooking? That's why I turn off my statuses on Discord. Discord RPC slimed him out. That's hilarious. I used to do reverse engineering back in my Nuremberg days. I was one of those, the cracks the cracked game copy, so the family is familiar with assembly. Oh, gotcha. I never participated. Never. But I was familiar with the wares scene way back in the day. Extrapolate from that what you will. God, I probably got so many viruses on my computer from Minecraft. Yeah. You also had to install an IntelliJ extension for that too. That's bad, man. Let's see. All right, so looking at this ret instruction here again. Oh, you know what? I don't think it cleared the challenge. Hang on. Start challenge, back to game. There we go. Now we're on stack frames. Okay. Stack frames is actually something I always had to muddle through. I know this is not the exact layout, like EBP's not like right here. This is like the main code segment, right? Hold on. Where's my marker? This is like the main code segment right here. I know EBP is not actually pointing here. EBP and ESP will move around depending on like which section of the stack you're actually operating in. And I believe that section being the frame is based on whichever function you're currently operating in. I think that was it. Like I said, it's been a long time since I worked through this. So this refresher course is actually very handy. Do you remember the Merc the Wares chats? No, I don't know anything about Merking Wares. Not a thing. That's what I said. I said Merc. I know. No one called it MIRC. Everyone that I knew at least called it Merc. Hey, Mechanic, what's up, dude? Swapped my laptop to a Fedora workstation. I have a Kali Linux VM running on it that I can remote to from my desktop. So I'm about to start doing Hack the Box stuff. Nice! Dude, the way that I usually, Mechanic, that I like to do that is there's a very nice setup here called Chasm VNC. And I really like it because it just runs in a web browser. In here, so it lets you do a lot of the stuff. Some of like the Control-C, Control-V stuff, I really like it, but that, because it's going through the web browser, gets kind of broken. So you lose some keyboard cowboy shortcut type stuff, but it works very well for interacting with it. If you've got better options, you could do this. Chasm is just a nice and dirty way to do this. In fact, like a bunch of my remote systems here at the house, I use Chasm on them. Allegedly, you could use Chasm to evade school restrictions. Allegedly. Yes, very yeah, allegedly, Potion. Let's see. For me, it was always called MIRC. Now, see, none of my friends ever called it MIRC. Now, keep in mind, this was back also whenever there wasn't a lot of voice communication, right? So it was purely text. So like in your group of friends, right, you'd all come to a consensus about how certain words were pronounced that wasn't general to anybody else. Yeah. Yeah, it works. It does work on the Chromium browsers. The control copy and paste and sharing the clipboard, that works just fine in Chromium browsers. Doesn't work at all in Firefox. But other things like when I want to close a window, Control W, it just kills Chasm. It doesn't let me like close the thing I'm operating on in Chasm. Yes, I'm gonna slap you around with a large trout. We actually had a game pack installed for Merc back in the day, Dirk, that it wasn't a game pack, it was some kind of a macro, but it would play different sounds. And so one of the things was, could you play the most annoying sound when somebody wasn't expecting it and their speakers were turned up? Like they didn't have anything playing, their speakers were turned up, and play it like in the middle of the night to like piss off other people in their house. Yeah, I was really good at that. I was really good at that game. All right, let's take a look at the stack frames here. Because actually, this is something I definitely need a refresher on. So the stack frames are the context of a function call. The stack frame includes the local variables saved base pointer from the previous stack frame. Okay. And the return address and the function arguments. So each time a function is called, a stack frame gets created. All right, at least I remembered that part. So before a function is called, the arguments had to be pushed to the stack in reverse order. After the arguments are pushed to the stack, the call instruction gets executed. The call instruction pushes the next instruction immediately after it onto the stack for the return to, basically the return to jump to. And then it jumps to the address that the call instruction points to. And it loads that, but does that by loading it into EIP. Cool. So once a function has been called, the prolog is responsible for continuing the setup of the stack frame. What the prolog does is save the previous stack frame's base pointer by pushing it onto the stack, rebases the base pointer to the value currently on the stack pointer, and then adjusts the stack pointer register to make space on the stack for the local variables. So it looks something like this. We push EBP onto the stack. We move EBP over to ESP. And then we subtract ESP by N. And N is a number of bytes allocated for local variables. And so like it makes sense when you look at the diagram, right? Because we're going towards lower address spaces. So by subtracting ESP, it's moving this value down. So that way we're basically adding extra space for the stack pointer to say everything between here and ESP is now our stack frame. Anything's better than the VM I had to use for class? I had 1 core and an Intel i9 and only 2 gigs of RAM. Ugh. So trying to run more than a small Word document, it took hours. Yeah. That's one of the reasons why I buffed up my home server so much, because I wanted to be able to allocate my VMs actual real world levels of assets instead of like choking them down. Can I run Windows Server on 2 cores and 8 gigs of RAM? Yes, I can. Is it optimal? No. Is it slow as hell? Yes. Do I like that? No. So that's why I put a bunch of RAM in here and can just crank up the requirements for it. Back before the great ramstering of 2025, when all the RAM ascended on high to the various clouds. Ugh. I still have not found a replacement drive for the NAS. I still need another 10 terabyte drive, but they're like damn near $400. And I used to get them for like $150. So all hyperscalers can eat a massive chode. What is Blobby VM? Hang on, check that out. Modified desktop on code spaces. I have to check that out later because it's a pretty bare repository. It sounds interesting. I've just never messed with code spaces. Let's see here. All right, so we massage our stack. We make a new frame in here. So the base pointer is going to be the reference to the current stack frame. So, okay, hold on. I got this backwards because I got to remember this is destination source. So we move the current stack frame into the base pointer here. So basically they trade places. So let me delete this real quick. Let's change this up just a wee bit. So this part goes away right here. So what we've got is something like this. Right, so our ESP points to the end of it, but EBP here boop, boop, goes like this. And then whenever we add like a new stack reference down here, right? So we add another function call here that when we run this, what had happened was we're now going to have a new allocation of things, right? And then ESP is now going to become EBP. Actually, let me do this in red. because then it will kind of... So now this is going to become the new EBP right here. And then down here is going to become the new ESP for this stack frame right here. So it basically makes an artificial adjustment. So this is our function prologue, but then also because of how we've had to adjust the stack frame, now we've got to have an epilogue too. So prologue happens when the function first enters, and then we're going to have an epilogue. So the epilogue is the opposite of the prologue. Cleans up for the function stack frame, and this is where the variables go out of scope and why local variable pointers can't be used for reference after the function gets returned. The first thing that happens in the epilogue is restoring the stack pointer back to the base pointer. So basically taking these out and swapping them back over from the red values to the white values here. Putting those back. So now we move EBP into ESP, right? So we move EBP over into ESP. Boop. So now they're pointed to, so this has been moved over to here. And then now this one aligns with this value here. And then we also pop the EBP value, which got pushed onto the stack here. So the white EBP value here got pushed onto the stack. Boop. Just like that. And then we return. Yeah, because the pop function says, hey, take what's on the stack, pull it off, increment the stack pointer, and then put it right here. Bam. Okay, perfect. So many times that move pop op instructions are combined into a single instruction called leave. Oh, so that's what leave does. It's a combination of the move and pop. Move and pop. Move and pop. It sounds like a really old school dance routine. I got this note from the technology coordinator. I didn't stop, I just got stealthier. Please stop screwing around with the proxy sites. Your activity is causing alerts to be generated that can go to the central office's technology director, who then alerts me. It's a violation of the acceptable use contract you signed when you started here. This activity will land you in hot water. I've never seen, and that confused me too, Dart, because I've never seen the leave assembly instruction. But right here it's saying, hey, a lot of times this epilogue here, right, this move and pop are combined into a single instruction called leave. I hadn't seen that before, but we're going to go with that convention for the sake of this course here. Can't stop, won't stop. That's right, Potion. Can't stop, won't stop. And yeah, here we go. So the stack grows towards those lower addresses. This means that when a buffer is overflowed, data is written towards the higher addresses, overriding the saved EBP and return addresses. Yep. Because you got to remember, what we're going to have here is we're going to have a return address, and then we're going to have a new EBP. So when data gets added, right, it's added in this direction. New data goes up like this, just like this. So then if we write too much data, that what we've got allocated into here, and we can control that return function, then we're Gucci. Now the problem is you also overwrite the EBP pointer here. ESP is hacker man, see through the walls. They should have just made the instruction, go away now. Yeah, like the critical drinker. Go away now. That's right, you couldn't be Elite Hackermans if you didn't have the Nintendo Power Glove. You had to have that and the little... What was it? The little monocle that Zero Cool's got, Crash Override, at the end of Hackers when they're in the phone booths, spinning around, do the awesome hacker montage. That's right. You got to have the power glove. You got to have the little monocle thing. That's the only way you got to be truly elite, man. I'm out of Jocko. I'm out of Sonic the Hedgehog tea, and I'm out of water. This is a travesty. Which 3D printing guy, Agent? I really want to get a 3D printer, but unfortunately the best ones, the bamboos, are kind of on everybody's shit list right now. You're late if you got monocles and Angelina Jolie. Dude, that movie came out when I was 12. I had such a crush on 19-year-old Angelina Jolie. Oh, Zach Friedman? Yeah, I've seen his stuff. Yeah. I never saw that he 3D printed the monocle though. That's awesome. Yeah, I have seen. Okay, so I didn't know his name, but I have seen his stuff. I recognized him as soon as I pulled up the picture of him. Who didn't have a crush on Angel Gita? I know, right? You need a rad skate to be a badass sysadmin. That's what the Hackers movie taught me. That's right. You gotta have a skateboard. You gotta have a leather trench coat. Story time. When I was learning about leaks and stuff, I thought it'd be a good idea to go by reporting to companies that got breached. Well, I quickly found out not to do that from school devices because I was then forced to dump 10 gigs of zip file PC logs. A lot of my friends that will do stuff like that, like breach collection, or they will do, they'll do that kind of work, that kind of like threat intel data, like trying to forensically gather the breach logs and stuff. A lot of times they have run-ins with the feds, so they have dedicated systems on different networks, different internet providers, and completely different hardware in there. Because then when they know the feds want to come in and pull the hard drive, they've even got like just hard drive trays in there, so they can just be like, "Yep, here's the drive." All right, let's look at this again real quick. So the key takeaway here is the stack frames are a way to save the context for each function call. Stack frames are created with very predictable patterns called a prologue and the epilogue, which the prologue sets up the stack frame, the epilogue tears down the stack frame. The return address saved on the stack is what controls where the execution goes after the function returns. Yes. All right, let's look at some frame anatomy. Yeah. Speaking of Angelina Jolie, we're going to do some anatomy right now. All right. So question here is, what is the return address? Oh, they don't give us the code? Sad. Yeah, I thought it was weird that that was Penn Jillette in the movie, because like I don't know if he's done any other movies, but I remember him in that one. I emailed Houston one day to get access to all their blueprints, and they emailed my principal asking if I got hacked or if it was real. And then I told him, no, it was real. I was just trying to help. I got reason to believe a system administrator or maintainer of your blueprints of the ports has had their device infected. After reviewing the breach release on a private Telegram group, I found the computer logs with information containing the following: browser histories, cookies, logins, and passwords to all sites, crypto wallets, applications, autofills, software and system information, and contained within the logs included access to private systems. Damn. But that's a very responsible disclosure there, Potion. So like I said, you doing that at your age, you're way above board right now. All right, let's see here. So what we're looking at is question number 1. What's the return address? All right, so if we go look at where we're at in here, we've got we have our variable 1, dead beef, and we have variable 2, which is cafe babe. That's funny. We have our saved extended, our saved EBP here. And then we have EBP plus some question mark. One of these values is the return address. Crap, let me think about this. So looking at let's look at our very awesome drawing in here. So it should be the one before EBP, right? So here's our saved EBP, but there's our local address. Local B? It should be that one. Nah, didn't copy. Copy. That's incorrect. Damn it. They were like, maybe don't reach out to companies through your school email. Bro, I'm just trying to be helpful. Yeah. No, Penn Jillette in Hackers, he was the helper for the plague. Let's see. Penn. He didn't have the leather trench coat. That was the plague. Penn. How do you say it? How did you spell it? Hackers. See, because of the images of him. Yeah, this guy. So the plague had the leather trench coat. This is the guy that was like,
Alert.
hey, Griffin, what's up, dude? Welcome in, Raiders. Funny timing, because we were actually just talking about the movie Hackers. What's up, everybody? Welcome in, Raiders. We're actually doing a little bit of binary exploitation tonight, but everybody in the chat's been like, hey, remember this? Remember that? Having some fun. How you doing, man? Sorry, I ran out of water and tea and energy drinks. I'm dying here. Yeah, type cookie, you idiot. There's a rabbit in the administration system. Let's see. Yeah, I think that I'm pretty sure I was 12 when that movie came out. Loved it. Maybe I was 11. Never fear, I is here. That's right, Kinslayer. But that was this guy. Which, by the way, he was actually really good in Blacklist also. Yeah, Rabbit, flu shot, talk to me. She was such like a dead ringer for the annoying C-suite. She nailed it perfect. I don't think she was a C-suite. She was some kind of like a manager, if I remember right. But yeah, she was like the quintessential annoying, no tech knowing anything manager. He was in Short Circuit too. I forgot about that. Well, he was in the first movie. I only saw the first movie a couple times. Short Circuit 2 was one of my favorite movies as a kid. Fisher Stevens. Yeah, that's his name. Wait, no. No, that was him? You're kidding me. How did I not know that? He was Ben Chibari? This is a genuine, how did I never know that? He did such a good job, I did not even know that was him. Holy crap. I love those movies. And now because I've said that, freaking every ad is going to be for like a build your own little Johnny 5 on my phone. I've gotten those plenty of times. Bro. Number 5 is alive. Bro, Griffin, you just made my night, dude. Because I had zero idea that that was him. Holy shit. Need input. Can I have these 2 books, craphead? Oh man, dude, the lesson here just got completely derailed. By the way, everybody who just came in on the raid, I didn't even introduce myself. My name's Blaise. I'm a professional hacker. I break into systems. Companies hire me. And we're just messing around. We're hacking around. We're finding out. In the pinned message in the chat, there's a cool little online course if you want to learn more about this kind of stuff. It's called Binary Jiu-Jitsu. I just found out about it Wednesday night. Wednesday nights we do hacker news for the week, interesting stuff. Someone brought it up. I thought it would be fun to go through. So Saturdays and Sundays, we're doing some kind of hacker shenanigans. Sometimes we're building tools. Sometimes we're just messing around and having a good time with it. And actually, this has been very fun because I have not done binary exploitation in like 16 years. So this has been a lot of fun to go through. Highly recommend it. It's free also. So you got no excuse. Let me see. So right now what we're looking at is we're looking at stack frames, and I'm trying to remember where the return address actually comes in here. Oh wait, no, this should be the return address right here. I forgot because it should tell us where to... Hang on, let me double check. So when we call this, yeah, so when we call a function, it's going to push the return or the current EIP onto the stack, and then it's going to decrement the stack pointer by 4 bytes because we're working in 32 bits, so it's got to move it down 32 bits, 4 bytes, and then let's see. So yeah, so we push EVP onto the stack, we move EVP to the new ESP pointer, and then we subtract how much space we actually need. This is whenever the function's getting set up. So before the push EVP should have been that one, I thought. But we don't have access to the remote debug. This is just everything like what's actually showing up in the stack frame in here. Oh, there's a remote debug. Damn it. Debug. Why did I have to switch to this to get the real one? I don't think there was a difference here. I'm not seeing a difference. Oh, let me reset this one. Reset it. I screwed it all up. I cannot believe Ben Javari was Fisher Stevens. That just blew my freaking mind. Oh Lord, the monkey's streaking here. Dude, 60 consecutive streams? Damn, monkey. That's some dedication. That's dedication to the crushing it life. These are all identical. I don't know what the difference is between the debug test and the real one. Here. Got to get the views, man. Dude, that's why I've been, like I said, I've been trying to push more, getting back into making the YouTube videos. Because I can't even get monetized on YouTube because you need to have so many subscribers, you need to have so many views on there. And I just honestly mostly used YouTube as like a live stream archive for a long time. But I really did want to go make videos for it. However, it always felt really cheap. Not to crap on Theo at all, but like what Theo does, where like he goes live to go record YouTube videos, I get that that is the optimal solution, right? Live streaming is very different from who's going to go watch a YouTube video. However, I feel like it's cheating the live stream. Hey, Disclosure, what's up, man? Dude, we're going for a few more minutes because I started the stream late. I crashed out before the stream started. Sock had to go wake me up. Yeah. I have thought about Monkey actually maybe like, hey, we'll officially end the stream and then maybe stay on while I'm recording and you guys can laugh at me. I just got to figure out how to do that setup because it's a completely different profile up in OBS. It's not what I typically use in here. I don't know, maybe I could go swap it around. I might just be able, no, that's not going to work. I can't run 2 copies of OBS, I don't think. And then even if I could, only one of them can use the camera. I don't know, I'll think about it. But I thought about like, hey guys, we're just going to we're just recording now. I'm just streaming that one on Twitch. And that's the way people know that, hey, we're actually doing something here. And here's just Blaise effing around and I'm going to go heckle him. What if those who missed the stream, they could have a shortened version? Yeah, that's true. But I like to keep, I don't know. Maybe I'm overthinking it. I don't know. But that's the way, that's the current plan going forward is find an interesting story that I like from the Wednesday night news stream. And then I'll have till Tuesday to script it, record it, and then polish it, and then get it up on the following Tuesday. Yeah, it's a chronic problem overthinking things, 57. Chronic problem. Surely that's not the return address. Okay, I'm going to take a hint here. So look at the stack layout diagram from the first lesson. Where does the return address live? Yeah, someone did that. Yeah, so we have our arguments, and then we have our return address, and then we have our saved base pointer, right? So if we look here, that's our saved EBP. The return address should be the one directly before it. And I tried that. It didn't like it. Yeah, our return address was right here. And it was the section immediately preceding. Now, actually, yeah, here's our high addresses. Here's our low addresses, right? Hey, Aswak, thanks for coming online, man. Welcome in. I hope you were having a fantastic Saturday. I didn't, dude, I'm so brain dead. I didn't even tell you about that. I hope you all are having a fantastic Saturday and have a very well Sunday tomorrow. Very well Sunday. What the hell am I even saying? I hope you're going to have a great Sunday tomorrow too. Spend time with friends and family. That's what Sunday's for. It gets you prepared for Monday's crushing it mode. Watching behind the scenes is more informational than most of the stuff nowadays. I mean, I try to keep the stuff like, for what I want to do on the YouTube videos, I try to keep it like, hey, it's a self-contained video. You don't really have to go too far outside of it unless you want to start going down rabbit holes. What if we got no friends and family? Find a game shop, dude. Every town just about has a game shop, and there's always people there like, go learn a game. And yeah, like Monkey said, you got a friend in me. Damn, I need to go watch Toy Story with the kids. Oh yeah, tomorrow's Father's Day, dude. Agent Zero is 100% a knockoff of Sock because he can't keep a secret to save his life, and it is eating him up. They got me a Father's Day present. I actually know what it is, but he doesn't know that I know. It's because it was purchased through Amazon, and I see all the Amazon orders. Anyway, he doesn't know that I know, and he is dying to tell me what it is. So he is very much looking forward to tomorrow to give me the present. I guess it has to be this address in here. I mean, even though this diagram isn't making a lot of sense, unless we're looking at it from high to low addresses. No, because there's local A, there's local B, right? Yeah, this is reversed because they get pushed onto the stack. That's what it is. Because remember, they get pushed onto the stack in reverse order. So if we look here, the arguments, when they get stacked, local A, assuming that's the first one, would be higher up in there. All right, let's go try that. Submit. Yeah. This is just a weird... There was a weird view of it. Not how I would have structured it, but I get it. Are you going to continue? Continue? Sometimes the web interface does get a little funky in here. Continue. Continue. There it goes. All right, so one other weird thing we've noticed in here is that occasionally we got to go back into the challenge. And then we got to go back out of the challenge to actually get it to clear the flag. Back to game. There we go. Now we can go down to the stack visualizer. Excellent. Super ancient niche laying eggs? Not quite. Are you a dinosaur? Yeah, I'm a wreck a lot of pancakes. Wrecks a lot of pancakes. That's what kind of dinosaur I am. New dino species unlocked. That's right. All right, let's see here. So they got something in here called the stack visualizer. I want to see this. So the stack visualizer gives you the opportunity to play with a live binary and observe the stack and registers at each instruction it's executed. Below is the source code for the application we'll be observing. Try to understand and anticipate what the compiler might do before going into the stack visualizer tool. Once you're satisfied, mark this as completed and continue your training. Okay, so let's see what it's going to do here. So we're going to have a void called vulnerable. It's going to define a 24-byte array char. So this is basically going to be 24. It's a char type. It's a buffer that's 24 in length. So it's going to be 0x18 in hex. So this is a 24-byte buffer in here. Enter input. It gets the buffer. So it writes whatever inputs we put into it. And then it says, you entered blank. Right here. So this is a classic stack buffer overflow. We have a fixed length input. We have a variable length. Oh, we have a fixed length container, fixed length buffer, and we have a variable length input, and we have nothing to check it in here. So actually, yeah, let's think about this. So what's going to happen here is we're going to have one stack frame for main, right? And then it's going to push its return address, it's going to massage everything, and then it's going to call vulnerable in here. So it's going to swap out, it's going to save the current EIP onto the stack. I think, hold on. Yeah, it's going to save EIP, and then it's going to jump to this instruction, and that next, actually, it's going to save the next instruction on the stack. So it's going to be like, what is that? EIP plus 4? Minus 4. Minus 4. Oh no, EIP plus 4, right? I know, we'll see. But anyway, then it's going to set up a new stack frame. It's going to move down EBP and ESP, right? So EBP is going to move down here. ESP is going to move down here. So we've got the basically like the main function up here. Then we're going to have the vulnerable function down here. Buffer overflows. What could possibly happen in production? Everything. Can you thread hijack on Linux? Actually, I'm not sure. I think so. A little bit beyond my wheelhouse. But I don't know. Maybe if we keep going down this, we can figure out. Let's see. So I want to see what the stack visualizer looks like. Let's see. Oh, cool. It actually will let us step through it. Okay. So we're in main right now. So we're getting ready to push everything onto stack. So we're going to push EBP onto the stack. So here's our stack, right? Here's our high addresses. Here's our low addresses. Notice how the hex is decreasing as we go down. So we're going to push EBP over to the stack. And we've got all of our registers right here. So here's EBP. So we're going to push that. We're at the main is the very first function. So we're like at the beginning of the stack in here. So then we call vulnerable. So when we call vulnerable, we're going to, if we look at what's happening here, then notice how we have EBP, we have ESP set up right here. So we are now going to push EBP onto the stack. So then we pushed that value. And then after this next one here, this is actually just like working in a debugger. You're just going like step by step. So now what we're going to do is we're going to move ESP over into EBP. So this value is now going to move down to here. We swap those. So now after this runs, we're going to see EBP have that D054 value. There it is in EBP right there. Boop. And then now we're going to subtract 18. Well, it's hex 18, which was our 24 bytes because we're allocating that buffer space, right? So we allocate that buffer space. That's going to cause ESP to decrease right here. It's going to decrease down to like right here, I think. Basically, that's going to cause ESP here to drop down to, we're going to subtract 18. It's going to go down to right about here, I think. I was close. I was off by 1. Classic programming problem, off by 1. Yeah, so now ESP dropped down, and now all of this is our buffer space for that char var that we had in there, that char buffer. And then we're going to call print. And then so print is going to do some stuff on here. So we're going to push the function. So call actually exists as a function in there as well, right? So now we're going to set up another stack frame to go over into the call function. Well, actually, I guess it just did it. And then now we're going to increment ESP by 4. So we're going to move it up a little bit. Boop. And then we're going to take the buffer back out. And then we're going to push EAX, which is the... Crap, what is EAX again? EAX is like a general purpose... Hold on. It's the EAX register. I got 98 problems and off by 1 ain't one. Okay, so EAX is like the general arithmetic IO function return value. Let's see. So then we're going to call get, and we're going to get some data from the user. And they don't send anything, so we get like a single null byte back. And then now we're going to start unwinding the stack as this happens. So we pushed EAX, but I didn't see what EAX was. Oh no, so we got that data, but then now we're going to push this value over into it. And then we're going to call printf again. User entered nothing. We got nothing. And then now it's going to start unwinding the stack frame. Bam. Just like that. And then now we're going to return. So remember, when we return, we're going to pop. Let me think. Hold on. Which value was it? It's been so long since I did this. I need to learn stack more. Dude, you and me both, Monkey. Like I said, it's been 16 years since I did this. I'm surprised at how much I retained in that 16 years. My sound blasters have EAX to make reverb. Dude, I haven't thought about Sound Blaster in forever. Sound Blaster, damn. Oh, let's see. We probably won't spend a huge amount of time on this. And we'll see after we finish up this exercise. We'll go see what else is like in the levels. I'm curious about it. And the reason is because I'll be real with you. Binary exploitation is one of the things everybody says they want to see on streams, but it's one of those things that very few people will actually basically grok, right? It's so low level in here. Now, this crew is a little bit different because we've got guys that do like embedded engineering and folks that are very interested in learning security. But I've even seen guys like Al Hazred, right? They tried to go do binary stuff on there and it just tanks the stream. And it's because it's so difficult to keep track of like what's happening in every step. All right, I got to remember where EIP is going to go here. So the return address is actually, I believe it's going to be this one right here. C8910408. I believe that's going to go up into EIP. Nope, I whiffed on that. Oh no, because EIP actually should go to the next value here, which was this 91C8. Yeah, I forgot that's actually where it goes up on the stack. Yeah. And then now we're going to leave, which is going to be part of cleaning up the main function here. And then we're going to return execution basically back to the operating system. Okay. Very cool. You want Bleeding Edge use Ghidra with AI? That's nuts. Well, if we keep going down this road, that would probably be eventually like one of the later events to kind of go through. Dirk would be, hey, cool, let's start going down the reverse engineering path a little bit. Lori Wire created a Ghidra MCP. I don't know if she made, I think there's other ones too. So yeah, here's Bethington. Lori Wire did make one. I don't know when she first released it. Not like it really matters like who made the first one in here. But yeah, she released this one last year. I'm constantly surprised at just how smart she is. I love her videos. She does great technical deep dives. If you've never seen her before, this is Lori Wired. And she does some really cool technical like things on her stream. Like looking at like really tiny things. Here we go. This is what I was looking for. And I love her set layout too. If you watch the latest video on YouTube, you'll see the green screen's gone. You'll see the disaster of an office. And I sent the video to some of my very trusted friends who I knew would give me like honest feedback on it. They liked it. But they all said, dude, you got to get a set going. I was like, I can't afford a set right now. It's a future plan. I figure if everybody just sees The Office, they know at least I'm not some weird AI clone. Yeah, I forget what her background is. Let's see. Now. Yeah, she did. This was actually her talking about this right here. So she's a professional reverse engineer. I think she has a very prestigious college degree, if I remember right, too. I forget. Let me see. More? Let me see. It doesn't mention it on here, but yeah, she's got I don't remember if she has a master's in computer science, but she's got a very solid educational background. And there's really cool ones in here, like this one, like your RAM has a 60-year-old design flaw. That was really cool. There was another one in here that I also really liked. The invisible backdoor, that one really blew up for her. So she's got some in here that like her channel's got, 500,000 subscribers, but she's got some videos that are way outperforming that. Like even this one, nearly 2x her subs. This one, more than 2x, way more. This one, almost 3x. So like she's got some really cool videos where like she just really nailed it out of the park. All right, let me go back here. Mark complete. Boom. Let's see. Let me try something real quick. I don't know if this is going to break it. Oh, it brought us back to the terminal. Go to the terminal. There we go. Hold on. While I was distracted fangirling over Lori Ward, let me see here. She scares me. She looks so sweet and innocent, and then you realize she's got very dangerous knowledge in that brain. Yeah. Yeah, 57, she is really awesome. Embedded stuff largely doesn't need assembly and machine code for like 20 years. All MCU manufacturers have long switched to ARM and use GCC, and 8-bit stuff has their own custom C compilers for it. Oh, okay. That makes a lot of sense, because if you're talking like everything being embedded is going to be machine code, like writing assembly, that's such a pain to maintain, man. They just out of an evolutionary necessity, they would have to have something to be able to go through with that. Oh, hey, Chris, what's up, dude? Lori's too pretty for me to concentrate on anything technical. She is. She is a very cute little thing. And you would not expect to have so much like dense technical detail in that very unassuming frame. But she'll like melt your brain out of like sheer raw horsepower she's got in that thing. Oh, you just got done submitting your Python homework? That's all right, Chris. We're getting ready to wrap up here. I meant to wrap up like 5 minutes ago, but I'm having a ton of fun with this binary ninja thing. Hold on. Where's my courses again? Jim? Here we go. All right, there we go. Let's go take the test real quick. Let's go see how we're going to do in this one. Challenge 1. Oh, do I want to do the challenge tonight? Yeah. If I don't do it tonight, I'm going to forget everything. All right, so after the prologue and local variable assignments in this example, list what's on the stack from EBP to the top lowest address. So what's the value at EBP minus 04x? That's going to be the return address in here. Well, hold on. No. EBP minus 1, that's going to be the last variable in there. So we're passing two variables, but they get passed in reverse. So this one actually gets passed in first, so 15, so it's got to be 5 in here. Hold on. That's not correct. What? Only assembly that I know left is the PSMs like the Pi Pico GPIO and some very specific DSPs like the Spin DSP. Hold on, let me read the question again. So after the prologue and local variable assignments. Oh, after the local variable assignments. Oh, okay. What's the stack look like here? It even says it. So yeah, I was reading this wrong because what should happen here is they get pushed in reverse order. So the last variable gets pushed first, which was 15, and then the second variable. So then EBP minus 4 would jump down to the first variable, which I was looking at. But we have something different here. We have integer x and integer y happening here. So the arguments get passed first and then the integers in here. So it actually should be 20. Hang on. Oh, the lesson is just a stripe test. Damn it. Let me think about this. I thought for sure I had the mental model correct in my head. Yeah, so EBP would be right here, and then we'd have the variables assigned in there. The Raspberry Pi Pico has one of those GPIOs so that you can make custom peripherals. Yeah. GPIO is not something I've messed with, but I really want to. Hold on. So if we're at EBP, we go down by 1. It's not 15, is it? No. So I thought it would have been 5 because 15 would get pushed in. Hold on. Yeah. I thought it was 15. So these local variables on the functions on arguments not used inside of example. So what they want to know is, what does the stack look like right here? So the stack should look like we're going to have our return address. Then we're going to have EBP, and then we should have the arguments passed to example. So that should be 15 and 5. But I already tried 15. That wasn't correct. But then we have X and Y being here, and that should have moved down ESP by 8. So it made room for those two variables. Those should have come next. Why wouldn't that be? EBP minus 4 would bring it down, right? So if EBP's here, it should have been the last variable passed to it, 15. Did I try? Yeah, I already tried 15. So example, initialize a static value on X and Y, but not use int A or int B. Hold on, but when the function gets initialized, aren't the arguments pushed onto the stack at EBP? Right? So we have EBP there, and then arguments, so in this case 15 and 5, get pushed onto the stack in reverse order. So it'd be EBP 15, 5, and then 10 and 20, right? Let's see. It can't be 10, right? Why was it 10? So, Almavar, are you saying that because it didn't use int A and int B, at this point we don't have them actually added into here? Hold on, so why was that going to be 10? I can kind of guess why it was going to be 10. Well, even with your limited English, you were pointing me in the right direction. You were doing well. Muy bien. All right, so now it wants to know which one of these stacks is actually correct. So we have 3 stacks here. It wants to know which one of these is the correct one. Sorry, I know it's the alignment's a little bit weird here. Hold on. If I bring it over a little bit, you can actually see it. Let's see. So it should be 15, 5. It's got to be A because that's the only one that matches it. Maybe I'm looking at this out of order. Is it? I think I'm looking at this out of order. This is the only one that makes sense, right? Because if it pushed them as 515, it's pushing them in sequential order instead of reverse order. So so why the past arguments if they don't use it in the function? Because the function defines that they should be there. That's basically why. The structure of it is a little bit different though. Hold on, so here's EBP, right? And so we're looking at the offsets. So the offset of where we are in relation to the stack pointer, right? EBP, or the base pointer of the stack frame. I think the problem I was having here is understanding the order of operations. It looks like it pushed the arguments here onto the stack, and it pushed them in reverse order, right? So it pushes 15, then it pushes 5, then it sets up the function. So then we have the base pointer here. Well, then actually, we need to know where to come back to, which is whatever the next operation is, right? So whatever the next instruction is, so then we save the return address so we can get back to it. And then we come back to, then we readjust the stack, and then we push a 10 and a 20 in here. So it's got to be A. Okay. I wish I spoke better Spanish. Okay, so we got that correct. All right, this is actually very insightful because it helped me visualize what was actually happening on this deck in there. I'm bilingual, I speak English and bad English. Easy there, Mr. Dallas. Easy there. Or should I call you Corbin? We're on a pretty good first name basis here. All right, guys. Unfortunately, that is where I've got to wrap it up. Super green. That's right. So that finishes up this guy right here. I wish there was a way to like, hold on, let me do this. If I go back over here, will it clear it out? Yeah, there we go. So we finished out. I finished you. Anyway, so I want to see what else they've got in here. So what's the blue belt? Oh, it doesn't let us like actually see like what's in the subsections in there. I'll have to see if they've got what else they've got actually got in here. Because that finished off the second stripe of the white belt. That's still a lot of fun though. I enjoyed that trip down binary exploitation memory lane. And unfortunately, we're the only ones online right now. Yeah. So let me go see who we can find to go raid over to. Sid's on. He's always good for a stream. He's always doing very fun electronic stuff. Let's see. Not too many people else online right now. Let's see. Shindigs is on, just messing around. Science is also on. Oh, but Science is playing Onimusha 3 Demon Siege. So yeah, we'll probably go right over to Sid. Because he's actually doing stuff in science and tech. I can see he's doing some kind of awesome electronics in there. Dude, he's been streaming for like damn near 10 hours. That's amazing. Looks like he's working on synthesizers again. Okay. Yeah, we're going to go right over to him. All right, guys. That's where I've got to wrap it up. I still got some more work to do tonight. Sock's already going to kill me. But thanks for coming to hang out. Had fun doing the binary exploitation. The test actually helped explain a couple things. Oh, let me see if this will work. Hang on.
The T-Monkey cheered 50 bits and says, "By the way, happy Father's Day."
Happy Father's Day, everybody. I hope you all have a wonderful Sunday tomorrow. I'm going to go hopefully take the kids ATV riding. The rain has been horrible here in Texas, and so it's pretty much rained on us every weekend. They haven't gotten to ride in almost a month, so it's been kind of wicked. So I'm going to go take them to do that tomorrow. You guys, tomorrow Sunday, make sure spend time with your friends and family. Get some recharge in for Monday's Crushing It mode. I need Monday Crushing It mode because I'm flying out to North Carolina. So that will be fun. But I will catch up with y'all tomorrow night. We'll do some more binary exploitation. We'll see if we can figure out like how far down it goes. So we can see maybe how far we want to go with this. I really like it. I just don't want people to feel like, hey, this is above my head and I can't follow along. That would make me feel bad. It defeats the purpose of the learning stream. So, but that's all I got for you guys. I got to run. I want you to remember one very important thing, and that is I love you. Peace.